One thing people always ask about, and I rarely do in production, is taking screenshots. But we're going to cover that now. Screenshots is pretty simple. What we do is we cast the driver down to a TakesScreenshot object. The actual interface for taking screenshots is not built into the WebDriver, but you can see that the remote WebDriver itself usually implements it. And we have one method on that object, TakesScreenshot, and it's the getScreenshotAs method. Now it takes an output type, which is an enum, as the argument, and we can say getScreenshotAs file, or getScreenshotAs base64, or getScreenshotAs bytes. File will create a temp file that we can access. So that's good if we're testing locally. Base64 will return a string in base64 format, because a file is a binary object, which we can then use. So if you're working remotely, getting a base64 string back or an array of bytes is useful, because then you can write it locally even though it's come from a remote server. Now we've got two ways of checking whether the driver that we're using can actually take screenshots. Now we can check if we can take screenshots by using the has capabilities interface. So we cast the driver to has capabilities, then we can use get capabilities and check if it does the capability for take screenshot. That's what the is method is there for. That's an easy way of doing it, or we can just try and cast it directly to take screenshot, and if it can't, it will throw a class cast exception. Now it's your choice which one you use. So we'll look at this in code now. That's just a quick overview. Essentially, we cast to take screenshot, then we have a single method getScreenshotAs. We can use has capabilities in order to check whether the capability is present, or just cast and catch the exception. Okay, I'm going to create a very simple test here to demonstrate the screenshots. So here I'm starting up a new driver. We're going to get a page. Then what I will do is I will cast that driver to take screenshot. I'm going to call this snapper equals, and then we want to cast the driver down to take screenshot. Now on snapper we have the get screenshots as method. So I'm going to say get screenshot as, and let's save it to a file, output type file. Since that's a file, we better create a field to store that in. So I'm going to call that temp screenshot, and let's set that up. Local variable, and it should be a file. There it is. So now we're going to a site. We're casting the driver down to take screenshot, then we're taking the screenshot into a temporary file. That would be good enough to demonstrate this, but what we'll do is I will just show you that it does put it out to a temporary screenshot. So let's print the temp screenshot path name. Then because it's a temporary file, we really want to control that screenshot and use it as part of our test reporting or whatever else, the other reason that we've taken the screenshot. So I'm going to say, let's create a screenshot directory for this. I'm going to store that just very quickly on my C drive. We better just make sure that that directory exists. Then what I will want to do is I will want to create a file to move that screenshot into. So in this directory, I want a file called, now typically I would create this file name randomly, and I'll show you that in one of the examples we walk through later on. Then I will want to move that temporary file. So we want to move the temp screenshot into this new my screenshot. Now what we can do is just double check that that file is not empty. Check that it works. So we want to say is greater than, oops, not great there, greater than, and that'll be a long. So we want to assert that is greater than. And what we'll do, just to demonstrate that it's taken this, let's open that in the browser. Because we've already got a browser, we know that browsers can open image files. So if I just say file : / and then add on the my screenshot, the one that we just created, then that should open it up in the browser as well. So now, if I stick debugs on here so we can see this as it goes through. Okay, so let me debug this test. So there's the page we're going to take a screenshot of. So this is basically saying let's create the TakesScreenshot, which it has done in a temporary file. So that takes a little bit of time. Good, no errors. So now if I go onto the console and print that out, you can see that it's gone into a temporary folder and it's a PNG file. That's why I made it PNG in the test. Now I want to create a ctemp screenshots directory, so let's just double check that that does not exist. cd screenshots, there's no directory called that, so let's make that. Right, so now I'm in the screenshots and that is empty. So what we'll do now is I'll create a new file to store that in. Now you can see here that that hasn't created that file yet, which is good news because otherwise we might not be able to overwrite it. So then let's move the file in there. And we can see that there is now a go to page screen file in there. And the length is not 0, so we're expecting this to path. Then if I just open that in the browser, here's what the browser currently displays. We're at seleniumsimplified.com. Let me open that local file, and that would just let us double check that the screenshot's what we expect. So there's the PNG file. This is the full page. If I zoom in, now we're seeing exactly what we saw last time, but this is a PNG locally that we're viewing. So I can zoom in and out of that. So that's pretty much how you take screenshots, shown live, and I'll walk you through some of the other tests that we've got around this in just a second. So your screenshot exercises are, first of all, check that you can take a screenshot. So create a Firefox driver, then use the get capabilities to check that you can create a screenshot. Then create another test which just casts it directly. Wrap a try catch around it and catch a class cast exception. You shouldn't get one with the Firefox driver. Then create another 2 tests where you use an HtmlUnit driver. This time use get capabilities, and you should not be able to create a screenshot. Then when you wrap it with a try catch, you should get a class cast exception. So these are really just 4 tests, 2 which can create, 2 which can't, and use the 2 different mechanisms, one with the get capabilities and one with wrapping it with try catch. And you can decide which one you like best for going forward in the future. Next up, I want you to, in these tests, first of all, make sure that your driver has the capability to take a screenshot, because you may decide later on to instantiate all the different drivers and see which ones can take screenshots and which can't. Then I want you to save the screenshot to a file with a random name in a location that you are controlling. Then create the base64 string and then save that to a file of your choosing with a random name. Then save it with a byte to a file with a random name. Now I've put some hints in there for those of you that may not know Java as well. You may have to do some Google searching to figure out how on earth do I work with base64 strings, how on earth do I decode them, how on earth do I write them out to files. I've put some hints on screen to help you, but again, we're putting this forward without showing you how to do it because it's Java, not WebDriver, and you have to learn how to look for this information when you don't know it. So give it your best shot. When we come back, I'll run through the tests that I've written fairly quickly, and then we can move on to something else. So the first exercise involved looking at the capabilities. So I have created a set of tests called Can We Take Screenshots test. And in the first one, I am using my helper again to create a Firefox driver. I'm going off to a website, my seleniumsimplify.com website. Now this is the answer to the exercise. So to check with capabilities, I've cast the driver to has capabilities. Then you can see that we have the get capabilities method, which returns a capabilities object. Then on the capabilities object, I can say is, then give it a capability name, and it will tell me is that capability present or not. I can get all the capabilities as a map of strings. Then I can get the browser name. I can get an actual capability, return that platform version. The is JavaScript enabled is really there for HtmlUnit, but it may work on the other browsers. Typically you just pass in the capability as it is, and you can see we've got a capability type object that has come from, there it is, the remote Selenium package. And if I have a look here, you can see that we have, does it support me getting the browser name, taking screenshots, yada yada yada. You can have a look through and see what capabilities we can ask for with the remote driver. Now these are basically there for when we set up a remote driver, we can set up desired capabilities, or we can set up must-have capabilities. This is what we'll use, but we can use it here to check for the capability take screenshot. So I'm casting the driver that has capabilities, getting the capabilities, and checking if the take screenshot is one of those capabilities. Then I'm basically outputting it to a file and checking that the file is written. So can we take a screenshot exception style? So again, I'm creating a Firefox driver. Here I'm casting the driver directly down to take screenshot. I've wrapped it in a try catch block where I catch a class cast exception. Now in this particular test, because I'm expecting the Firefox driver to cast perfectly well, in my catch block I put a fail clause. So if when I cast a Firefox driver to take screenshot, if I cannot to do that, then this test will fail, because I'm expecting to be able to do that and to write a screenshot. For the HtmlUnit driver, what I'm doing here is casting the driver down to has capabilities, then saying get capabilities is screenshot enabled, and in here I'm saying if this returns with a true, if HtmlUnit now does take screenshots, this test will fail. Then you can see for the HtmlUnit with the try catch block, I've cast it directly down to a take screenshot, and if it moves on to the next line, I put in a fail clause because I'm not expecting this cast to happen correctly, so it would fail. I'm expecting that when I do this, a class cast exception will be thrown, and then I will just print out the stack trace. So that's the can we take screenshots, checking the capabilities through the casting down to has capabilities, and also wrapping it in a try catch block to catch the class cast exception. Now you get to choose in your tests as you go forward when you're using screenshots which one of these is most appropriate for your needs. So the next exercise was to use the screenshots, the different type where you can get file, base64 or byte, I'm just going to run these tests. The reason I'm going to do that, normally we wouldn't do that, but you can see over here, I have this resources folder. When these tests run, they will create a temp screenshots folder in here, and they will write these screenshots out. So I'm just going to show you these tests so that we can see that the actual files are output. So there's the temp screenshots directory being created, and we have our first file in there. And there's our second file, and you can see that I have named them based on the test. So the first one is type file, second one base64. And then I have a random string being put in there to help make the image unique. And there we go. So all three of my tests passed, and I have 3 images out here. Now if I double click this in IntelliJ, IntelliJ should be able to open up the image that I can check. And there we go. IntelliJ is letting me view this PNG file. So let's have a look at these tests. So the first test I have in the persist screenshots test class is persist output type file. Now again, I'm just creating a driver. I'm using my driver manager to do that. I'm creating a Firefox driver. I check capabilities, that the capability TakesScreenshot is present. Then I take the screenshot as an output type file. I'm just checking the length of the temp file to make sure it did write one. And this is where I'm controlling the file. So all my screenshots are going to go in a temp directory for screenshots. So I've wrapped that up into a local method. Then I create a new file name for it. So this one is persist output type file. Then I generate a random date, well, I generate the current date, but I format it in a string to make the file name unique. And you can see here that because this is an actual file that is returned back, I'm pretty sure it's going to be a PNG, but I'm not taking that chance, so I'm going to get the extension from the temporary file name and use that as the extension on my new file name. And again, that's a local method. And we'll have a look at that in just a second. So then I do what you'd expect. I create a new location for the file to move into. I move it, then I assert that the new one is not 0. I could assert that it's the same length, but that's pointless because then I'd just be checking the fileutils.moveFile method. So hopefully you did something similar for your persist output type file name. Let's have a look at the create directory. Now the only reason I've put this in a method is that it gets quite big. And I'm basically saying, get me the current user directory, which because we were in the IDE, will give me the root of the projects here. Then I'm saying, go into /source/test/resources. And the reason I'm putting these %s in here is just in case I ever run this on Linux or Mac, I can get the appropriate operating system file separator and stick that in my string. So source test resources, temp screenshots. Now temp screenshots didn't exist when we started, so I first of all check if the directory exists. If the directory exists but is not a directory, then I fail the test straight off because I don't want to bother trying to debug this if I'm trying to write to an actual file instead of a directory. If it doesn't exist, then I make it exist by calling the makeDirs directory. Then the only other thing you saw was the get extension. Now this is not a robust method, and all it really does is say, starting from the end of the string, find the dot, then give me everything after that dot to give me the extension. That will work fine on Windows and the various ways we're using this, but it's not a particularly robust method. So then comes on to the base64. Now all these tests are pretty much the same. They create the driver, they check for the capability, they create the directory, they create a file name with the string. The only difference is going to be in how we create that file. So when it's an actual file coming back, all I do is move it into the correct location. When it's base64, I have to decode it first into a byte array. Then I can use the file output stream to write that byte array into the location that we're looking for. So there's nothing really complicated in there. I create a new file, I use that as the file output stream location, then I write the bytes that have come back from decoding the base64, then I flush that file to make sure that it's finished. Now you can see here that because I'm converting it into a byte array here with the decode, you're going to pretty much expect the as bytes method to be pretty much the same as this, but not have these lines. And that's almost exactly what happens. So I can check capabilities. So for bytes, we make sure that we output type bytes, set up the directories in the file as before, create the file location, then simply output that byte array that comes back from get screenshots as into the file output stream that we've created. So hopefully you did something very similar. There's nothing that complicated in there. But remember, we use the output type file when we're running locally. When we're running with a remote WebDriver, we want to use either base64 or bytes. And the reason you would choose between base64 or bytes is more in terms of whether you want to do any processing on that image beforehand. So this is a short introductory overview of mobile automated execution with WebDriver. And we're focusing using Appium, and the examples are Android. Now the reason it's a short introduction is that we mainly focus on the WebDriver API. We're mainly looking at automating browsers rather than native apps. And all you're really doing when you're working with the mobile application is creating a remote WebDriver connection to a server and then running the tests on the mobile device. That's essentially all you're doing, but any of the libraries that you use, Selenium, Appium, they have way more capabilities than that. So it'd be doing a disservice to those tools if I said we covered it on this course, because really you want to go into those in more detail. If you do it, it's probably out of scope for a lot of you, so we just provide an overview. Now there's been a few different ways of doing mobile with WebDriver. We started with Android driver. That was quite simple. You instantiated an Android driver, new Android driver. You ran an Android app on the Android device, which acted as a Selenium grid hub, and you connected to that using the IP address of your Android. Selenium, I think, can be used for web, but I think it's mainly aimed at application testing. I haven't used it. The default now is Appium. Appium is pretty good, as you'll see. You can find the information at appium.io. It's got all the documentation and downloads that you need, so if you decide to go into Appium in more detail, it's worth going through the site and having a look. Essentially, it's an application written in node.js that runs as a WebDriver grid hub. So it runs, it sees what devices you've got connected to the machine, it allows you to use them as part of a grid. When you connect to Appium as a remote connection, it will install an APK onto your device and connect to that and communicate with that in order to run the tests. So for this section, what I'm going to suggest you do is watch as many of the videos as you can. Certainly the videos about what is Appium, how do we install it. You'll see when I'm fixing some of the tests in some of these videos that you'll see how I'm debugging tests, how I'm running Appium, how I'm swapping between the IDE and Appium. That might give you some more ideas on how to use Appium. And also, whilst I start showing you examples with the physical device, I'm going to recommend that you wait until you've seen the examples of me running against the Android emulator with Android virtual devices, and that when you do the exercises you should really start with the AVD. That allows you, even if you don't have a physical device, to use Appium and experiment with it on a mobile emulator. You'll also find a basic transcript for this set of exercises and the slides. installation can be more problematic than it should be. Essentially, there's only a couple of steps, but they can go wrong. So we have to do this in small stages. And I'm going to walk you through those small stages now, but I'm not going to show you the entire process just because it takes long, and it is essentially simple. What you do is you head off to the Android Developer Studio site, then download it. If you want, you can download the full Studio. I didn't. I just downloaded the command line tools. Now I suspect that if you download the entire Studio, you probably get a smoother install process, but given the choice between 1 gig or 128 meg, I chose the 128 meg option. Essentially, I just download this Windows application and run it. For Mac, it's just a zip, follow the instructions. On Windows, I installed it to my D drive to avoid any permission issues, and during the install process, the Android SDK Manager runs at the end of the install. Let me just get that up. This is the Android SDK Manager. What I tend to do is, this is what I have installed. The most important things are the tools, the platform tools, and the USB driver for our purposes. After you've done the installation, it's worth adding the Android tools to your home and your path. So create an Android home variable, which is where your Android SDK is installed. This is the main Android SDK folder. I create an environment variable for that. Then I add the tools folder and the platform tools folder into my path because I want to be able to run these tools from the command line. There's one of the main tools that we use, so Android, to type in Android SDK to bring up the software development kit manager. ADB is in platform tools. ADB is the Android debug bridge, and it's the main communication tool for connecting to the Android device. So it's important that we have those in our path. Some tools rely on the Android home. This just means we get set up a little bit more. Once you think you've set up your environment variables, check that you can do Android SDK and bring up the SDK manager. Check that you can do ADB version to make sure that your ADB is running. You can read more documentation online, and the more you get into this, the more you'll need the documentation, but initially we don't really need to do very much. So make sure all that is working before you go forwards. One of the things that I found with Appium installation, if you skip a step, you have a whole compounded set of issues and you really don't know what is next. On your phone itself, you need to have USB debugging enabled, which means you need to put your Android phone into developer mode, which you do by going to the About and clicking on the device number 7 times, I think it is. You can find all the instructions that you need on the Google site. Because essentially what I recommend you do are follow the instructions for getting started with the remote debugging Android devices from Chrome. Right, so that would tell you how to enable USB debugging to get your phone connected. Essentially, Chrome has the ability to inspect connected Android phones. If that isn't working, Appium isn't going to work. So the best place that you're going to find instructions for getting the phone connected to your device is on the remote debugging Android devices site. And essentially it should just be put your phone into USB debugging mode, connect your phone once the SDK is on. That uses the Google USB driver to connect your phone. Then the Appium uses the ADB to connect to your phone. Now if your phone is working properly, when it's connected, when it's on USB mode, when you've accepted the connections, if you go to Chrome Inspect, you'll see your phone there. Now the important thing for Appium is that number next to your name, that 4GH562, that's your device ID for the Android, and we use that to connect to the device in Appium. When we have multiple devices on the grid, we need that device ID. So this is what the remote debugging tools lets us do. I've opened up, this is all on the phone, by the way, this is a remote session onto the phone, and it's showing me in the browser. I can navigate around in the same way that I would do if I was controlling the phone. I can see all the cookies that have been set up on it, and I can inspect the elements just as I would do if I was running this on a normal desktop browser, but I'm doing this remotely through the phone, which can be very useful for debugging purposes and for helping us test. Now, if all that works, then we install Appium. So head off back to the Appium site. Now you'll see that on Appium, there's the big download Appium. What I've found is that this points to an older version of the app. At this current time that I'm doing it, it's pointing to 1.4.13.1 of Appium. If I go off to the main downloads section and go to the Appium.exe for Windows, if you're using Mac, just click on the OS X one. Now I can see that Appium for Windows is actually 1.4.16.1. If I had used the front page, I'd be running with an older version of Appium. We want to use the most up-to-date one, so just come to the downloads link, click on the right, desktop app for what you're doing, and download the most recent one. It should be a fairly simple install process. When Appium runs, essentially what we're concentrating on are two buttons, or one button essentially. The Start Server button, and when we start the server, we see a bunch of information come into place, and then we can stop the server, and we can clear the log over time. Once we start the server and we see all the logging information come through, that means that we can connect to it as though it were a grid hub, and you can see the information that you need on screen there. It's running on address 127.0.0.1 on port 4723, and then I use the normal grid hub connection URL /wd/hub, and then I would be able to connect in WebDriver. So essentially what I'm doing is when I want to connect to Appium when it is running, I use the device name as a capability that we saw earlier on when we were doing the Chrome inspect tools. You can also get that information when your phone is connected by typing adb devices at the command line, and you'll see the device number. We set the platform name up to be Android. I use Chrome, so we set the capability for the app to be Chrome, and then it's just a matter of connecting to it as a normal remote WebDriver on the URL that we had, the 127, the localhost 4723/wd/hub, and then once we have our driver, we can use it like a normal driver and run all the tests. Because remember, that test run that you saw me do earlier on had no changes made to it. It was just a normal remote driver running those tests. So for the next couple of videos, you'll see Appium in action. Okay then. Alright, so I'm just about to start running the test that we've got against Appium. I haven't done anything special to the tests. I've just configured the driver to connect to Appium running locally, and it's the same test running. You can see I've got the very physical setup here. The phone is sitting there, it's connected via USB into the computer. I'm running everything locally. So let's get this started. I'm going to start the Appium server. So there we go, Appium's getting commands, the tests have started running, and stuff should start appearing on the phone. There we go. There's some commands coming through into the phone now. Now the reason I'm doing it like this, not setting up any screen sharing or anything like that, is just to demonstrate that this is working live on a real phone. In this video, we're just going to look at what I had to change in order to have the tests run against Appium. And it wasn't very much. All of the changes I made were in the driver class. So you can see what I've added. I've added a new Appium into the browser name. In order to not mess about, I've just amended the driver class to the default browser as Appium. I've added a new section down here for if it's Appium, then call it Appium. Then some more code in the Appium section here just to start it up. So all I'm doing here in the Appium section is creating a desired capabilities, setting the device name to be the name of my device that you saw when you do ADB devices or when you use the Chrome debugging tool, the Chrome inspection tool for Android. It shows you the device name. And all I've done is add that into an environment variable called Appium device name so I can make it easy to change. I'm setting up the platform name to be Android. I'm telling the app to be Chrome. Appium is running on the local host on port 4723 on WD-Hub. All of that information is from Appium itself. Then I just set up a remote WebDriver and we're done. It's much the same as we do when we're setting up SauceLabs or when we're setting up any other grid. It's just that to make it simple for myself, I've hard-coded some of the platforms. And that was it. Nothing else. Then I just started my test as normal. It uses Appium, picks up the environment variable, runs the test against that. I didn't change any test specifically, so we get a fairly good amount of compatibility with Appium. There was one other change that I had to make. Down here, so what I normally do in the driver tests is maximize the window. So when I do a get, I maximize the window. Now I did have code in here for unsupported command exception, because when you use a remote driver you can't maximize the window. Appium doesn't throw an unsupported command exception, it throws a WebDriver exception, which unsupported command exception is derived from. So I've just put in an extra bit of code here that says if it's a WebDriver exception and it's Appium, then catch this because we're expecting it, and just print out Appium does not support maximize, and I'll see that in my logs. Those were the only changes that I had to make to get Appium working with the code that we've got. If you're going to experiment with Appium on your own, all you need to do is when you instantiate the driver, instantiate it like this, set up the desired capabilities, make sure you set up your device name, make sure the platform name is Android. I recommend using Chrome. Make sure you set up a remote WebDriver to the WD-Hub on the port on the host where your Appium server is running, when your Appium server is running, and then you'll have a driver, a remote WebDriver that you can use to connect through into Appium. So let's investigate why these tests are failing. So I did not expect the BasicTestRefactored to fail. So I'm just going to rerun that and see if there's a problem. So to do that, and you're going to see this a few times, you're going to see me start Appium, stop Appium, run some tests so you get used to it. We're also going to investigate it, run the test in debug mode. You'll see some evaluation going on. This should give you a good idea of how we debug tests. So I'm going to start up Appium. Appium's running. I'm just going to rerun that test. So that all passed. Clearly that was some sort of intermittency. What that really tells me is I need more control over the test environment, which is why I'm writing an application where all the files are hosted within Java. So I can download a Java app and test all the test pages through that. Probably also means I want to avoid going through to the Compendium Dev site and the Selenium Simplified site so much. So I'll probably change the code to do that. But that test essentially works, so that's just an intermittency I will put that down to. And I'm not really going to investigate that in any more detail. Okay, so let's investigate the cookies test. What I find interesting about the cookies test is that we have two very similar tests in here. I've got the cookie exercise test work with extra sync, and I've got the cookies exercise. Now if I look at both of these, and I do the compare files in IntelliJ, the only thing that's really different are a few extra asserts and some extra synchronization. So which one of those failed? So change cookie visits during cookie builder. All right, well the first thing I'm going to do is I'm going to run the test again and make sure that it still fails. So I'm going to stop the Appium server, clear the logs, start the Appium server up again, then let's run that test again. Okay, so let's have a quick look. So this fails asserting the size of the cookies after deleting a cookie and adding a cookie. This does the same thing, assert, deleting. Okay, so what we're going to have to do is I'm going to stick a breakpoint on there. I'm going to run this test in debug mode, and I just want to see what is going on. So the server is still running. I should be able to just start this test in debug mode. Okay, that's not the breakpoint I'm looking for. Keep going. Okay, so what I want to make, I'm concerned that maybe when we delete the cookie, it doesn't delete, that kind of thing. So what I'm going to do is evaluate that expression. So driver manager.get cookies. I don't know if you use the evaluate expression, but it's how I debug things. So I can see that when I evaluate the get cookies, now I've got 3 cookies in there, the 3 Selenium cookies. So if I move down to the next line, it will delete the cookie that we're expecting. Let's see what happens when I evaluate this now. So get cookies, it has deleted the cookie correctly, so that's good. So let's add the new cookie. Okay, now we can see the problem. We actually have a ChromeDriver cookie being added when we run it on Chrome through the Appium. So the issue here isn't that the test is failing, the issue is that I've deleted a cookie and now I'm checking to make sure that I've got the cookies that I want, but there's actually an extra cookie being added. So what I'm going to do is I'm going to add in a domain specific condition here. Let's run this test to finish. Essentially what I'm saying here is I run the test, I delete cookie, I add new cookie, I expect to see the number of cookies correct. But because Chrome is adding one, I could put in a workaround that says if we're running an Appium, then check for one less. But what I really care about is when I delete this cookie, and add a new one, have I only got the 3 Selenium simplified cookies? So what I really want to do is not just say, tell me the number of cookies. Instead, I want to say something like, so the number of Selenium simplified cookies. Now, if I put that in here, I can then just create a local method. I don't want a key store, I want a set of cookie, because that's what comes back when I do cookies normally. So let's start by return so that would make no difference to the test at the moment. So if I ran this now, the test would fail every time I use that. Instead, what I want to do is I want to create a new local version. So I'm going to create a new set of cookies and iterate over the cookies that are in the Selenium cookie jar and just add those that start with Selenium simplified. So look at all the cookies that are in driver.manage.get cookies. Then if cookie.getName.starts with, so if it's a Selenium simplified cookie, then, and then I will return that subset. So what I've done is I've created a subset of cookies instead of, so Chrome now should be able to add as many cookies as it wants, but we only care about this. So let me fix the test that we're failing. So I'm going to count the number of Selenium simplified cookies we had, delete one, add a new one, double check that we've still got the same amount. So I've only added the one. Then let's do the same thing here. Right, so if I run those tests again, they should pass. So the Appium server should still be valid. So let's run those tests again. Okay, so that was interesting. That was a cross-platform issue. It only happened when we ran on Appium. I don't know if it was the WebDriver interaction with the Chrome on Appium or whether it's the Chrome on Appium or whatever. Essentially, my test wasn't domain specific enough. My test assumed that when we add a cookie here through the Selenium API, it's only going to add one cookie. It's not, all I really care about is, has the cookie been added? Do we have the same number of Selenium simplified ones left? So I should have made my test more specific, which it is now. Have we managed to delete a cookie? Have we managed to add a cookie? And it's fixed. Rather than putting in an Appium specific check, I've made the code domain specific for what I want to check. And this should work on every other browser going forward. I don't need an Appium specific test for that. Okay, the user interaction exercises tests all fail. Now initially I was thinking that, yeah, this is probably just the user interactions and they maybe don't work properly on Appium. But what I can see here is actually the tests are all failing at the point that they try and synchronize to make sure the page is loaded. So what I'm thinking is that maybe the element to be clickable stuff doesn't work on Appium, but maybe everything else does. So what I'm going to do is I still want to have some synchronization in here. But instead of synchronizing on clickable, I'll synchronize on, is the element actually there? And what I'll do is I'll say, so if we're actually running an Appium, then just finish. So everything else, we'll check whether they exist. If we're on Appium, then we'll just return. If we're on any other browser, then we'll check that they are actually clickable before doing anything. And let's see if that makes a difference. So our server is still running. So let's just run the test. Okay, so that was all due to my attempt to
compensate for browser errors in the past. Appium was actually working fine. So that tells me that in my test code here, I've probably been a bit too specific for browsers. I should probably be using page objects, but we're not using page objects in this part of the code. And really that's my issue, but I've got a workaround here that works fine. And what's interesting is when you go onto new platforms, you discover errors in your code. You discover assumptions you've made. You've discovered that you've hard coded to what's actually happening in the browser rather than what's happening in your domain. And we have to rework it. We've been really fortunate that Appium's working really well at the moment. So I'm just having to do very minor changes. But that is the user interactions one. So the user interactions is working fine on Appium. Okay, so we have issues with the basic data-driven test and the CSV-driven test. And these are all the same, right? And it's basically saying when we click the button, we wait for the answer. It times out waiting for the answer. So I suspect we're not actually clicking this button. So what I'm going to do is I'm going to break point here, and then I'm going to run the test in debug mode and see what we can see. So the server's still running, so I should be able to just debug this. So the form comes up, we type in a number, we choose something in the drop down, we type in another number, then we find the element, and we found the element. So what I'm going to do is I'm just going to evaluate this. This is what I do a lot. I evaluate the expressions and see what we can do. So I just want to make sure that I can do things on this. So calculate button dot. Let's get the tag name, see what happens. So we've found the button, we've got the tag that's an input. Looking at the screen, it looks like it's zoomed in and we may not be able to click on it. So I'm just going to force a click now. So if I click now, evaluate, see what happens on the screen. Nothing. So I clicked on it, but nothing's happened. So what I'm going to do is because it's an input, it's part of the form, it does the submit, I'm actually going to submit it and see what happens. And so I can see on the screen now that the calculator has done something. So I suspect now if I close this, let's continue through. Right, so that worked. We're now on a different part of the test. So now if I get that element again, I'm going to evaluate this. So I know that click doesn't work. I know that this would fail, but I'm going to evaluate this. I know that I can submit it. So the other thing that I can try doing is sending keys. So if I do keys from Selenium, that's right, dot enter. So if I send an enter key, we've got that on focus. So essentially we're saying, right, I'm on focus on this. I'm going to press the enter key, and that submits it as well. So there's something odd happened here because we're running on Appium. And really I would need to code a workaround at this point for Appium. So I know that click will fail. So if I just run this, the test will fail. What I'm going to do now is I'm going to put a workaround in the code, and I'll just go for the submit to start with. So let's say in this basic data-driven one, we just submit. So let's keep going, we're in breakpoint, let's just cancel this. Right, because I've stopped the test, what I'm going to have to do is stop the Appium server, starting it up again. Let's clear the logs. There we go, that's ready. Let's run the test again using the changed code, which instead of doing a click now does a submit. Now there's probably other workarounds that I could do. If I used the actual Appium driver, the click might actually work because it's doing a proper finger tap. I could get the XY coordinates and possibly use an event to tap on it. There's a whole bunch of different workarounds. I've just picked the first two that came into my head, the first two obvious ones from using this kind of stuff before. And the tests are working now. So again, that shows this one was a platform specific issue. I don't know that I'd want to just have .submit and enter key on the other browsers, although that might be perfectly valid. So what I'll probably end up doing is just putting if it's an Appium, then do a submit. Otherwise, let's just do a click on it. So let's code that up. So if I'm working in Appium, then submit. Otherwise, now again, this should be in a page object somewhere. So I should be saying click on the calculate button or do a calculation, and it should handle all this for me. It should be abstracted away. But because in this particular test we're not using page objects to show this, we wouldn't have this. So again, this fix needs to go into the CSV driven test, and it's a copy and paste because we're not using page objects. If we're using page objects, this bug would already be fixed. So those two data driven tests should now be working. And Appium is still running, so it should work fine. Great, so that's all working now as well. So the earlier testing that we did was on a physical device. Android also supports emulated devices, AVDs, Android virtual devices. So what I'm going to do is show you how essentially they work, talk about those for a little bit. Now, I can start up the Android Virtual Device Manager by typing Android AVD at the command line. I have an Android virtual device created here. It's using the API level 23. So if I start this up, you can see that I can start and stop Android virtual machines here. I've got it set up to 120 by 1920. I'm going to wipe the user data just in case. Launch this. So now I've got Android working in a virtual machine. We've got simple commands here, so I can get menu, I can go home, back, all the little buttons. We can power on and off, rotate it. There's extended controls where I can do more things more easily. You experiment with the emulator as you need. Essentially for automation, we don't really need very much. We just need an emulator sitting there with a browser on working. Now this is running Android API level 23, so it doesn't actually have Chrome installed in it. So if I want to do automation on this, I would have to use browser. So I'll show you that later on. And the emulator is accessible to us through the normal ADB commands. So we can see that this emulator is emulator -5554. So if I wanted to connect to this with Appium, that would be the device name that I would use. So if I just get the browser up, I can just do normal browsing here. And I find that the inbuilt browser is not quite as good as Chrome, but it's what everyone uses on their phones pretty much, so that's what we tend to use. I didn't use this on the physical device testing, by the way, mainly because on my phone the browser gives me trouble. It doesn't start up normally, so it's very hard for me to demonstrate browser on that. But I find Chrome is more compatible for automating on the browser, so I prefer to use that. But when people insist, then we drop down to the browser that's on the machine. So let me just close this, and then we'll go through the steps of how you create your own Android virtual device and how you use it as part of your automation. And now we'll go through the process of creating our own Android virtual device. Now I can start up the Android Virtual Device Manager by typing in Android AVD. What I tend to do is I tend to use the SDK manager as my main start point for any configuration that I do. The reason for that is that the Android SDK shows me everything that's already installed. So I can see here that I have installed the SDK for 25.17, Platform Tools 24, Build Tools. I've got the Android N API 24 SDK installed. And I've got the API for 23 installed with some system images. In order to create an Android virtual device, I need system images. So what I'm going to do is I already have system image for 23 installed, so I'll install a system image for 24 so we can compare them. I've got the Google USB driver installed, which we need to connect the physical devices over USB. And I've also got the Intel x86 emulator accelerator installed. Now I need that installed for a device to actually work. Now if you look carefully, you'll see that this is the actual HACS installer, not the actual emulator accelerator. So once you've installed the installer, you then have to go off to your Android SDK and install the actual emulator accelerator. So assuming that I had installed the installer, I would go into where I'd installed the SDK, Android SDK in the extras folder, in Intel, in the hardware accelerated execution manager, and then I would install the execution manager. It's very simple. Install, you run it, then you might have to reboot, you might not, I didn't have to. Okay, so let's install one of the system images for Android N. So I'm not gonna pick the Android TV one, but I'll pick both of these. I'll download both and I'll see which one I can get working. That's pretty much how I work with these things. Let me accept the license and install it. These are fairly large files, so I will edit this video down so you don't see exactly how long it takes. So I've downloaded 2 system images. Now I can create them. So the main reason that I use the SDK manager is simply that I can download what I need and then I can go and use it in the AVDs. So I'm going to go and create an AVD for Android N24. So the easiest thing for me to do is to start with the device definitions. So I'll create an AVD based on this device definition. I'm going to call it AVD for Next 7 by Google, N for Android N, that's what we're going to install on it. I'll leave the devices Nexus 7, target set up for Android N, CPU is the image that we downloaded, I'll pick x86. I'm going to use the skin with dynamic hardware controls for more configuration. Now I can see here it's giving me a warning about RAM. I'm going to leave it 2 gig. My machine can handle this without any issues, so you might want to adjust that based on your own things. And I tend to use host GPU. It's faster and sometimes it's the only way I can get these things to start. But again, you should, if it doesn't work out the box by doing this, experiment with the different controls, see what works, experiment with a different system image just in case. Make sure you have the HACS-M emulator installed from Intel. And then hit OK. So now I've created a device, so I can just start this as we did before. If you've got an error message with the HACS-M, it will appear in here. There it says HACS is working. If you had an issue with that, it'd say probably HACS is not working. Okay, so here's my Android device, and you can see that Chrome is installed on this one. Now, what that means is that I should be able to use the Chrome remote debugging. So if I just do, there the emulator is running on ADB. If I get Chrome running, so there is our emulator. So if I open a tab here, There we go, that's opened it in the emulator, so I can do things like inspect. And then we can work with this as though we're on a device. This is again useful when we're building our automated code. We want to know what elements we're working with. We want to experiment. Working in the emulator and the Chrome inspect can be really useful. And that's essentially all we really need to know about creating AVDs. But if I want to actually automate at the moment, I need to drop down to use API 23 version. So if I have a look at the configuration of this, the main difference is it's using API level 23. This image, once I've selected API 23, comes from the 23 part, but everything else is exactly the same. You can see I'm using the host GPU, it's the same memory config. But the difference is because the system image is from API 23, it doesn't have Chrome installed on it. So I'm going to run basic test against an Android AVD. I'm going to start up the API level 23 Android AVD. While that's starting up, I'll get Appium started. And you can see I'm using Appium 1.4.16.1. So let me start Appium. Okay, so I've got a test over here, ready to go. It's configured. Basically, I'm hard coding in the name of the device, emulator 5554. You can see 5554 on top of the AVD. I'm saying it's platform. I'm using App Browser because Chrome is not installed on this device, and Appium is running on 127.0.0.1 on port 4723. Let's double check. Port 4723. Okay, so this test should just run fine. Let's try this. There we go, so that all worked fine. Now if I change this to Chrome, right, so that failed because Chrome isn't running on this device. So the only thing we have to watch out for is making sure that we're targeting a version of Android or AVD with the right version that we need that's compatible with Appium with the browser that we want. API 23 and below browser. If you want to use Chrome at the moment, you're better off using a physical device. Eventually that will not be the case, and you'll be able to use Android N with versions of Appium. I don't know exactly what version that will be. I imagine it'll be fairly soon because Android N will be released very soon. But this gives you the option to experiment with mobile and Android testing even if you don't have a physical device. Alright, so I'm just going to run the tests on the API 23 that we set up. Okay, so that's not bad. The tests that have failed on the normal browser in the Android emulator are frames, which we're expecting. Submitting a form. And that's it. And the reason you're not seeing the file upload failed is that I've taken that out of the Android class here, and I've taken out the Windows management one to make it a little bit more stable. So these are the tests that I would expect to work on a mobile device, and the only ones that have really failed are the frames, which I was expecting, and some of the submission ones. So that's a pretty good pass rate, given that we've made very few changes to the test code to actually get it to work on a different platform. So for exercises, what I want you to do is try some of the things you've seen in this section. The best thing for you to probably do is make sure you download and install the Android SDK, download and install Appium, and try and run some test through the Android virtual device. Right, do that first, make sure that's working. So you've seen that I had to set one up with an API level 23 for the version of Appium that I was working with. If you've got a later version of Appium, a different version of the API might work, but we know that API 23 works, so I'd probably start with that. But create an AVD, get it working, experiment with that, then try and run the very simple Android test in the source code, Android test.java. It's in the package com.seleniumsimplified.webdriver.mobile. If you can get that running on your AVD, then you know that you can experiment more with Appium on your machine. And then if you want to go further, you can try with a physical device. You can amend the driver code and run the entire Android suite that's in the test code base. But you've got enough information there to experiment and possibly extend your existing test work into Appium if you really want to.
We're going to have a quick look at continuous integration. Essentially, it's out of scope for this course, but everyone keeps asking, how do we get our tests running in continuous integration when we're using WebDriver? And that's what this section is all about. Essentially, if you can run your test using Maven from the command line, you can run it in continuous integration. But we're going to go over a little bit about some of the pros and cons, different ways of using the drivers, how you run this from the command line, how you set up suites, profiles, things like that. So continuous integration essentially is every time we check code into our version control system, the continuous integration system will continuously monitor that, and when the code changes, it will check it out, build it, execute whatever tests we've told it to, and report on that status in the continuous integration system and report any errors. And you can configure this in very complicated ways so that it emails things out, that it automatically deploys it afterwards and becomes part of a continuous deployment and delivery process. But essentially it's simple. We check something in, it builds the code and tests it for us. We can also have it so that the build runs periodically. So you might have heard of a nightly build or a daily build. Say we have certain tests that are slow, like the WebDriver test. They might run for half an hour. We don't want that running every time there's a check-in. So what we do is we run that every 6 hours or nightly when everyone's gone home, we check it in the morning. Hopefully we do it more often than that. Hopefully we have a pipeline so that we run a set of tests fast, we get some fast feedback, then it goes off and kicks off the tests executing the GUI in parallel to other execution. I mean, we can make this build process as complicated as we want. In this set of videos, we're going to make it very, very simple. Essence, we check in, it builds and tests for us. Because we're just given a high-level overview here, there are a whole bunch of different places where you can get information on it. So Martin Fowler has a good article on what continuous integration is for. The book Continuous Delivery is very good, explaining how this fits into the overall development process. There's books on every continuous integration system. So there's books on Jenkins, there's wiki pages on Jenkins, there's websites showing you how to do all this. I'm going to show you some examples, but not in detail. And obviously there's an article on continuous integration on Wikipedia. There are so many continuous integration tools. I'm not going to list them all. There's a list on Zebia Labs you might want to have a look at. The main one that I use is Jenkins. Jenkins is open source. We can run it locally. It's very simple. It runs using Java. That's the one we're mainly going to use in the demos here. I've listed a couple of others here. You're also going to see a demonstration of Travis CI. Travis CI, because I've got code on GitHub, Travis CI is a hosted open source continuous integration server that will automatically run the stuff that I check into GitHub, and it can run WebDriver tests on Firefox as well. And ThoughtWorks have got one called Go. There's a whole bunch. So feel free to experiment with them all. In practice, pretty much every place I've ever worked has used Jenkins. So let's have some examples. I'm going to show you how the CI works in practice, and then we're going to go over that in more detail. Okay, so let's see some examples. Now I have created a special code base, which is a cut down version of the code that we use in this entire course, specifically for the purposes of putting it into continuous integration. You can find the code on GitHub at github.com/EvilTester/wdci. That's WebDriver Continuous Integration. You do not need a GitHub account in order to use the code or build a local continuous integration server. However, you might want to in order to experiment further. The code should run on HtmlUnit, should run on Firefox, should run on the IE driver. You will need to configure the paths to run against IE, ChromeDriver and Marionette, the same way you would do normally by setting the driver path, which you've seen in the driver code already. So let's have a quick look at the code. So this is it on GitHub. If you go off to GitHub, you can have a look and you can explore the code by looking through. Now what I've done is there is a tools directory here. I have not included any of the drivers in here. If you want to, you can check this out. You can put the drivers in here. You can run it if you want. Essentially, when you run this, you're mainly going to be using the paths to control the driver. Either add it in your path environment variable or control the path at the command line. And we'll cover how to do that later on. But you can see here that we have the build passing symbol. That's because when I check in the code to GitHub, it also uses Travis CI to run the code and check that the build is passing. You'll see an example of that in just a couple of lectures time. The code is what you're used to because it's the same test that we've had, just a very cut down version of them. And I have amended them slightly to allow them to run on HtmlUnit. And we've got a couple of very simple suites, and the POM file has been cut down in order to support our executing with minimum profiles. But again, there's comments in there, and we'll cover all this on the course. But all of this is to stop you having to create an account on one of the other version control sites to access the full source code. And remember, the full source code for the course doesn't run on all the browsers because it has edge cases and other examples. So this is a cut down version of the source to make things easy and to allow you to get started faster. And that's why we're using Git, because it seems like everyone everywhere now pretty much uses Git. So we've chosen Git as the version control system. We're going to install Jenkins locally, and you're going to see how all this stuff hangs together so that you can put something very, very simple together to run your tests under continuous integration. But start with the example that we've put on GitHub at github.com/EvilTester/wdci. So if this is your first introduction to continuous integration, I'm going to show you a very quick example running Jenkins and triggering a job manually. So I'm going to start Jenkins up. And I access Jenkins in a browser on localhost port 8080. And there's Jenkins. And here's a bunch of Jenkins jobs you can see. Essentially, Jenkins these are all the jobs I've got set up. Jenkins is telling me that this one is unstable, it passes, it's failed, or it's passed for a while, it's failed for a while. These ones are all stable, and these are the ones that are all using
the code that's on GitHub, the EvilTester /wdci, very simple build process, and these are all working. So I am essentially going to just start up the Firefox one. Let me build this now. So that build is starting to run. What we can do is we can monitor the build as it's running. Let's have a look at the console output, and we can see as if the test was just running from the command line. Now the test is actually running in the background. That is the browser, even though you can't see it. But the test is essentially running through on Jenkins. Now very often if I'm working with the test locally, I will trigger the builds manually. But in a proper continuous integration process, we would have it polling the version control system or doing it on a time basis. Now that the build has run, I can look at the test results, and it will show me all the tests that have run and whether they've passed or failed. Now a lot of people are always asking, how do we report on the tests and the status of our test execution? Pretty much this is what I do. All I do is I rely on the build system reporting on the test execution, and I try and make the names of the tests easy to understand to get an understanding of what we are covering. Use the package structure to understand what we're covering. Where possible, I try to keep everything simple. I try and use the tools as they are. I don't really want to add in too many extra parts in the build process to complicate it, because here we can see exactly what ran, exactly what failed. We can see all the output. We can track everything that we hopefully need to in the build process, and if something fails, we need to investigate it in more detail, then we'll drop down into a debug process to do that. And that is essentially a demonstration of Jenkins. We'll go into Jenkins in a little bit more detail later on. So I've just run the tests in the CI project. What I'm going to do now is commit the code to GitHub, and then that will automatically trigger a build on Travis CI. So I'm just adding a quick commit message. Now that has committed it to my local version of the repository, so what I have to do now is push that on to GitHub. So that should be on GitHub now. I'm just going to get the Travis CI up. So we can see that Travis CI has seen that GitHub has had a new check-in. So it has started a build. And there's the build I added suites. This is really what continuous integration is for. You make some changes, you run it locally, you check it into your source code repository, then your CI pulls that and runs the tests to make sure everything's going on. Travis CI is a hosted CI system for open source projects that are using GitHub. I think you can install Travis CI locally and you can use it as part of your environment, but pretty much I just use it for automatically running tests against the open source projects that I have on GitHub. If I want to do any work locally, then I'll use Jenkins. And really I set up Travis CI simply to get that build passing logo on the test code, and to use it as an example to show you how CI works. So here Travis is telling me that it's running against Oracle JDK 8 and against Oracle JDK 7. So I skipped to the end where both builds have passed. What we can do is I should be able to click through into the build now, and I can see all the output that was run during the execution to standard out. And I can see that we ran it on HtmlUnit and we ran it normally, which would be using Firefox. Now you didn't see Firefox browser start up there, and that's because in Travis
we've set up Firefox to run as a headless browser. I mean, not strictly a headless browser. What we've done, let me get the code for this up. So Travis is controlled by a YAML file, and all this code is on GitHub, so you can have a look at it. What this YAML file says is we want to run everything against JDK 8 and JDK 7. Before running the code in the script, I want you to start up XVFB, which is on Linux, which is a way of having GUI screens come up under X windows without actually seeing them, which means it will start up Firefox, but the browser window will not be shown. And what the test code here does is, first of all, it runs all the tests using HtmlUnit, and then it runs all the tests using Firefox, but it's essentially running without the GUI being displayed. Now you can do this if you're running on a Linux machine or a Mac machine to run Firefox tests but without the browser being displayed. But the basics are, when I check in the code, the continuous integration system picks up those changes and runs a test for me and reports it. So let's have a look at Jenkins then. Installing Jenkins is not hard because we don't actually install it. What we do is we download the WAR file, which is a Java web archive file, and we can run it from there. So we have to head off to the Jenkins website. Then just follow the links for downloading Jenkins. We want the long-term support release. Download that WAR file. So then when that downloads, all we do is move that WAR file into the directory we want. And just to keep it simple, I've got it in c:/Jenkins. And so long as we have Java installed, which we should do at this point in the course, I can do java -jar jenkins.war, and it will start it up. Now Jenkins runs on port 8080 by default. If you get a conflict when it's running, then change the port when you start Jenkins. All the instructions for doing this are on the Jenkins website. Then when Jenkins is up and running, we go off to localhost port 8080. Now when you start Jenkins for the first time, it's going to ask you to set up passwords and user accounts. It's going to ask you whether you want to use the default plugins. Just say yes. It's going to guide you through the install process or the setup process as much as possible. Just take all the defaults that you can. We are going to add some additional plugins, but take the defaults. Now to manage Jenkins when it starts, we use the Manage Jenkins list. So in here, we want to add some plugins to start with. The plugin that I'm going to ask you to add, if I go off to Available, then filter for Maven Integration. Now you will see it in the Available tab. I have it installed, so it's not showing in my Available tag. But you go off to Available, do a search for Maven Integration, and then install this plugin. It's pretty much just click install. You don't even need to reboot Jenkins. What this lets us do is when we do new item at the start, we'll have a Maven project. The icon might be slightly different for you, but we'll have a Maven project icon, and that makes it a little bit easier to set up Maven projects, which is what we're going to do here. The EvilTester /wdci project on GitHub is a Maven project, so by installing this it'll be a lot easier to get working. The next thing we have to do are make sure our tools are set up. Now you should already have a JDK and Maven set up, so it's just a matter of making sure they're configured. And in the global tool configurations, you can see I have JDK set up. If your Java home is set up correctly, hopefully Jenkins will have picked this up for you. Same with Maven. If you've got your Maven home set up, Jenkins will hopefully have picked it up. If not, just add in the path where your Maven is, or add in the path where your JDK is. Now clearly we don't have Git installed yet. We're going to need Git to check out the code from GitHub, so we have to install that. But you can see how simple setting up the Git tool is in Jenkins, and it will pretty much happen, or should happen, automatically once you've got Git installed. And that's really all the configuration we need to do for Jenkins. And this is the same on Mac as it is on PC.
So just in case anyone's confused, we're going to do a first time run through of Jenkins. So you can see I have downloaded Jenkins. I've got the war file in c:/Jenkins. I've got a command line up in that directory, and then I would just type java-jar jenkins.war to start up Jenkins. So if I do that, so we can see here, it's telling me that during the install it's created an admin user with a password. So if I go off to the Jenkins URL now, I have to copy and paste in the password that it's generated there. So I'm going to get it to install the suggested and most used plugins. That will cut down on the installation I have to do afterwards. You can see it's going to install various Git plugins, Subversion, so all the version control plugins I might need. The important one for us is really the Git plugin here. So really we should keep this nice and secure, so I'm going to create an admin user called admin with the password admin, and then we can start. So before I start, I'm just going to manage Jenkins and add in one of the missing plugins. So this is what it's installed by default, all of which is quite useful, but there's nothing there about Maven. We're using Maven. So I'm just going to go off to available, and then I want the Maven integration plugin. I'm going to install without restarting. And that will allow me, when I create a new job, to create a Maven project. So then all I should really have to do is the global tool configuration. So I'm not going to install it automatically because I've got one here. I'm just going to say Java 8.1, and that is in, let's find it, JDK. Then Git is set up by default because we've got all the normal Git things installed. Then the only other thing we're using is Maven, and I have version 3.0.4. So I've got 3.3.9 as well. Let me set up 3.0.4. And then save that. And that should be it. I should be pretty much good to go at this point. Git is a version control tool. That is the tool that most people seem to be using in the real world now. And that is what we're using on the course now. So we have the source code on GitHub, github/EvilTester/wdci. And in order to check that out, we need to use Git. Now you can access that code by downloading a zip file from GitHub directly without needing an account. You can check out the code once you have Git installed without needing an account. Now there's so many different ways to install Git that I'm just going to walk you through the process rather than demonstrate it in action. There's the official Git site, and that has downloads for Mac, Windows, Linux. It has good instructions for how to set it up. And remember, the first thing that you will be asked to do for any Git setup is to check whether you have Git installed already or not. So if at your command line you type git -version and you get a prompt back, it means you have Git installed. Now on a Mac or Linux, when you type git -version, you might even be prompted to install Git. I think Git might even come by default on many Linux and Mac distributions anyway. It's mainly Windows that you have to install this stuff on. Now, because the code we've got is on GitHub, there are also instructions on how to set up code on GitHub. And GitHub have a GitHub desktop that can make it quite easy to access Git.
This is my GitHub desktop, and you can see it's listed on my GitHub projects as well. Now GitHub desktop installs a version of Git for you. The problem I had with GitHub desktop was that it didn't add git.exe to my path. Now GitHub desktop installs a whole set of tools in your user's app data local GitHub folder, and in the portable Git folder are the commands that we want to use from the command line. So I had to add this path into the path variable to allow me to use GitHub after just installing the GitHub desktop on this virtual machine. So as well as the official Git SCM site, as well as github.com, you could also use the instructions over at Atlassian Bitbucket. GitHub gives free Git accounts and Git repositories. Bitbucket does the same. Bitbucket lets you have private Git repositories as well. And again, there are getting started instructions that explain how to set up Git here. Now GitHub desktop, Bitbucket have their own GUI called SourceTree for running Jenkins, and from the command line we need to have the git.exe. So you might find that the home page for Git is the easiest one to try, the Git SCM. You could always use Tortoise Git if you're on Windows. I have that installed. But the important thing is git ---- version must be working from the command line after installing Git for Jenkins to work. So now we're going to put everything together. Now if you haven't installed Jenkins or JDK or Maven or Git or whatever else, then follow the instructions in the course to do that. The prerequisite for this is that you have javac. It runs from the command line. Maven running from the command line. Git running from the command line, and you have Jenkins installed and running. Because what we're going to do is we're going to create a new item in Jenkins. I'm suggesting a name, GitHub wdci Firefox, because we're going to run the code that's on github.com/EvilTester/wdci, and we're going to run it in Firefox. And we're going to do that by executing the POM file that's in code/pom.xml. And we're going to use the Maven goal test. So these are rough instructions here because they'll get you used to using the Jenkins GUI. You've already seen me use it throughout these series of lectures. So hopefully it's obvious what you have to do. Try this out, see how you get on. I'm going to go over the exact steps for doing this in the answer, but hopefully it's obvious what you have to do here. Okay, so let's create a job in Jenkins. If I go off to Jenkins, I'm going to create a new item. Let's give it the name GitHub wdci Firefox. I'm going to make it a Maven project, and then I'm going to say OK. So now I'm going to tell it where the Git repository is. It's this one here on github.com/EvilTester/wdci. Now, when that red text went away, that was Jenkins checking whether it could access the repo and whether Git was installed. So there's no error message here, so we should be good. Here it says build whenever snapshot dependency is built. I'm just going to leave that set just now. But what I need to do is in the build, I need to change this because our POM is not in the root folder, it's in code/pom.xml, and we want to do test. And that hopefully should be good enough. So if I save that, I should be able to build now. And we should be able to see in the console the code working, it doing its checkout, then running the tests. Okay, so that all worked okay. Let's see what the status is telling us. Now, because we used the Maven integration plugin and the project we set up, it's captured the test results for us. We didn't need to do any extra work to configure this. So now we have all the test results tracked in Maven, so we can review this stuff if we need to. Great. And we've got the console output to see what's going on. We've created our first Jenkins job. It pulled everything out from GitHub and ran successfully. So our next exercise should be fairly simple. Based on the previous job that you created, when you create a new item, Jenkins has the ability to create it based on previous jobs. So create a new item based on GitHub wdci Firefox that we created in the last exercise. Then all we're going to do are change the goals and options so it doesn't just do test. It configures the test to run with the HtmlUnit driver. And to do that, we need to set the Selenium 2 basics.WebDriver property that the driver class uses to decide which driver it's going to use. Okay, hopefully this was fairly simple, but let's have a look at the answer. So on the Jenkins dashboard, we can see that I have the GitHub wdci Firefox project. So what I'm going to do is I'm going to create a new item. If you want to create a new item from other existing, you can use this. So I'm going to do GitHub wdci Firefox, and I'm going to give it the name GitHub wdci HtmlUnit. Now I shouldn't have to select one of these projects because it's copying it from here. So let's do this. Okay. And it's got the right name. It's got the GitHub repo we want. And it's got the previous setup. So all I have to do is in the goals and options, put in -d, and you can see I've done this before. Type in -d Selenium 2 basics.WebDriver equals HtmlUnit. And those are the same instructions that were on the slide. So if I save this, and again, I'm just going to build it now. And if I go off to the build and see it running, now I shouldn't see any browser for this because it's using HtmlUnit, and it may actually be a little bit faster. So I won't need to speed up the video. So it's going to run through the tests. So the test passed, but it was slow enough that I will need to speed up the video. But again, going back to the status, our test results have been captured, everything is good. And now we have the ability to run in Jenkins our tests in Firefox and HtmlUnit with the code coming down from GitHub. So this time we're going to be using the create a new item based on a previous one. We're going to set up Selenium 2 basics.WebDriver property to configure the browser that we're going to use. But it's going to be one of the browsers that needs a driver. So Firefox Marionette or the IE or Google Chrome. So whichever one of these you have the driver installed for, work out which path you have it installed to, then configure your Jenkins job to use that browser and set the property for that path. So if you were going to use IE, you would set the property webdriver.ie.driver and point it to the executable, which is IE driver server.exe. So I was going to use IE for this, but I've already used IE in this section, so I'm going to use Google Chrome. So let me get Jenkins up. So I'm going to create a new item, and I'm going to base it on the HtmlUnit one, because the HtmlUnit one already has part of the browser stuff set up. So let's GitHub wdci, and I'll call it Chrome. Click here to get rid of that. Okay. So now GitHub wdci Chrome, there's the GitHub repo, and we've got HtmlUnit. Let me change that to Google Chrome.
because that is what is specified in the driver. Let me add a new property, -d WebDriver.chrome.driver equals, and then of course I have to go onto the disk to find it, and I've got it in c:/WebDriver ChromeDriver, and it is ChromeDriver.exe. So let me save this and build now, and hopefully Chrome will start. Okay, so I suspect then that it's not Google Chrome, it is in fact Chrome. So I'm just going to allow it to be Google Chrome, and by the time you watch this, it will be Google Chrome compatible. So let me go back and check this in. And then let me put that into GitHub. And now, if I go back to here and run this again, oh, I'm getting a mess. There we go, it's running in the background. And as soon as this build finishes, the next one will immediately start. That's the joy of working with this. So let me get back to here, Jenkins, which gives us the benefit that I get to show you how to cancel a job before it starts. So if I click this, then that job is cancelled. So that we still have this one. I can look at the console output. It's still running in that browser, and it's finished. Well done. So that was a little bit longer than expected, but a lot of good things in there. You saw, completely intentionally, you saw the errors happen in there. We debugged them. We fixed the error as part of the continuous integration process. We released it. In fact, the test will probably now be running on Travis. There we go, that build is still in progress on Travis. So because we fixed it, we checked it into GitHub, our normal continuous integration process is running as well. What a splendid demonstration. So let me get back to here just to recap. So that was the normal Git setup, code pom.xml, test, set up the browser to Chrome or Google Chrome, and change the path to the driver executable. Now remember, if I had installed ChromeDriver on my actual path, I wouldn't need this line, and it would pick up automatically from WebDriver. So I just left that to the end to show that the Travis build is passing as well. So what I'm going to suggest you do is create your own account on GitHub or Bitbucket. Bitbucket allows you to have free private repositories, so if you want to do stuff and have no one see it, Bitbucket is a good bet for those. GitHub, you pay for the paid plan, but you can have as many free open repositories as you want. So both GitHub and Bitbucket have instructions. Use those, create an account, create your own repository. And what I'm going to suggest you do is you add your code, the stuff that you're doing as part of this course. Any applications that you're working on to explore your skills and automate. Say you're trying to automate Redmine, or you're trying to automate To-Do MVC, or you're trying to automate Get On Tracks, or some open source or public application, or even if you're trying to automate Google, whatever you're trying to do. If you add your code to public repositories, then check your code in there, then you can use your own code and experiment with that in continuous integration. What I'm going to ask you to do is not add the source code that you find in the zip for this course, because there's a lot of it. You'll find it hard to run on the continuous integration, and if you give away all the source code for this course, then there's less incentive for people to sign up, and that would be bad for me. So please don't release the source code for the course, but do release any code you're using for exercises or any code that you write on your own. Now, one of the benefits is GitHub can act as part of your CV. I mean, that's pretty much why, if you look on my GitHub, I try and release as much as I possibly can. Right, this is old projects from when I had an Atari ST. Right, pretty much I don't care. If it's code that I've written, it's going up here. It saves me having to have a local storage of it, and it just makes it public. And it basically says, look, I can do code, and I've done code for a while, and I used to do C and assembly language and whatever else. I think even my old university project is on here somewhere. And there's actually useful stuff as well. But the essence is create your own repository with your stuff. It acts as a profile for you. And if you're getting stuck with your code and you release it to GitHub, you can point people at GitHub and say, why is my code not working? Please help me out. So just as an exercise, get used to checking these things in, because we don't cover that in the course. We don't cover how to use Git or how to check things and how to create repositories. You'll have to follow the instructions for that. But it's a worthwhile activity. Get yourself used to version control systems, and particularly version control your own code, because it will act as an offsite backup as well. So one of the questions people often ask is, how do I only run some tests, or how do I partition the tests so that all the failing tests are run separately from all the tests that are pass? Now, there's a whole bunch of different ways of doing that, but the one that I'm going to suggest to you, I think, is the simplest, and it's using JUnit suites and potentially using Maven profiles to help you execute them. So starting with JUnit suites, you can find the documentation for JUnit suites on the JUnit 4 website, which is on GitHub. But essentially what we're doing is we're creating a class. This class is called InterrogateOnlySuite, and it's an empty class because we're using annotations to make it a suite. So the two annotations that are important are the @runWith annotation, which says use the suite runner for this particular class, and the tests that you're going to run, the classes that form part of this suite, are in the annotation suite.suite classes, and that is an array of classes. So you can see that this suite contains a first find by example test, the chaining find by example test, and the find by CSS selector example test. So if I run this suite, those three test classes will be run. Now I can run this suite from the command line with maven clean -d test equals InterrogateOnlySuite, and then say test as the target. That means I could put suites into continuous integration without any problems. Now you'll notice that I haven't put test in the name of the suite because I only want it to run when I target it specifically. If I put test in the name, when I do maven test, it will run the suites as well. I don't want to do that, so I haven't put test in the name. So I can run this from the IDE. Let's have a look at that. Here's my suite. In the source code GitHub wdi project, you'll find an empty suite that you can use as a basis for your own. The InterrogateOnlySuite actually has more classes in it, but I can run this class. I can right click and do run, and it will run it as a normal test because JUnit can see that it's running with the suite runner, so it will pick it up and it will just run through the class. Or I could run it from the command line with the maven clean, then specify the actual test, and that means I can run it from continuous integration. Now, typical reasons for doing this are when you start putting your tests through continuous integration and you start running your tests on different browsers, they're not all going to work. Some tests are going to fail on Marionette driver, and you won't want them to always run as part of the suite because your Marionette driver execution will have errors. So typically what we do is we organize tests into different groups so that when we run on Firefox Marionette, we only run the tests that will pass on that. And we might have a failing Marionette build that we are still investigating that only runs nightly or every couple of days. And when tests start passing, we move them out there. It's different ways of managing our test process and making sure that our builds pass more often than they fail, and the intermittency is not something that drags our project down. And suites are one way of doing that. So the other thing we can do in conjunction with suites is create a profile section, and you can find profiles described on the Maven project. What profiles let us do is they let us run plugins and configure plugins. So the plugin that we're using, or you're going to see me use, is the Maven Surefire plugin, which allows me to include and exclude specific test classes from the run. So here I've created a profile called ImTests, which uses the Maven Surefire plugin and includes both of the suites that I've set up. So interrogate only suite and manipulate only suite. So this isn't running all the test classes in the code, this is only running those tests that are specified in those suites. So if I had created these suites for passing on Firefox Marionette, then they could be included in the Surefire plugin here, and we could have a profile that only ran the tests that pass on Marionette. I could have another one that only runs the tests that fail on Marionette to allow me to investigate it in more detail. And it gives me a way of organizing the tests again into different execution. And profiles can be run from the command line. Maven test -p ImTests would run the suites defined in the profile ImTests. Maven test would just run the tests ordinarily, the normal set. I could add additional properties, so I could run maven clean -p ImTests and select the browser to run on as normal, right? Because we're just chaining the properties, chaining what we want to run, chaining the target we want to use, the test target. And because we can run it from the command line, we can run it from continuous integration. So this is a long exercise if you choose to do it. Basically what we're saying is take your existing code that you have been writing throughout this course and run it against the different drivers, the different browsers. Run it in continuous integration. And when you do that, some of the tests are going to fail. You're going to have cross-browser failures. Some of them are going to be easily fixed. Some of them are going to be limited by your driver. I mean, for instance, in the continuous integration code you've got, I had to change the tests because HtmlUnit doesn't support getText, and some of the tests were failing because of that. So I changed them so they didn't rely on getText. When you identify what's failing, what you can fix easily, what tests you're going to have to work on, start putting them into different suites. You might find that some of the tests you just can't get working under Marionette. Put them into a fail on Marionette test class, or put them into a suite where they will never run on Marionette. Try and organize your tests into suites and profiles so that you can have different Jenkins builds or different profiles that will run reliably even if some of the tests fail on some of the browsers. You're going to learn a lot about cross-browser testing when you do this, and workarounds, and investigating the tests and splitting them up into tests, suites, profiles is something that we end up doing in the real world quite a lot to make our builds stable. Now I've got a couple of lectures showing some lessons learned as I did this on the main code for the course, but not on the CI one, because the CI one is a cut down set of tests, and I do recommend you use your own code or the code that you've been working on during the exercises in this course and try and run those on as many browsers as possible. Just a quick run through of what Jenkins is doing, just in case you're curious. I mean, you can read all this in the Jenkins documentation, and it is worth reading through the Jenkins site to understand how it works. Essentially what Jenkins is doing, you're running it from WAR-file. It has an environment property called Jenkins_home where it stores all its information. By default, that is in your user folder. So here for me, it's c:/user/alan/.jenkins. And this is where it is storing all the information in config for the work that I'm doing. And you can see that there's a jobs folder that has all the different jobs and folders for jobs that I've set up in Jenkins. And sometimes if I'm in a hurry, and you're probably not supposed to do this, what I do is I'll copy one of the existing jobs and then stop, restart Jenkins, and the job will be there and I can amend it there. Same for when I've got a folder of jobs, I might want to copy the entire folder and edit it. There are different ways of working with Jenkins, but sometimes I will do that. Now the main reason I'm showing you this is that sometimes I don't want to mess with my main Jenkins folder. Now I can easily back up this main Jenkins folder that's in c:/user/alan/.jenkins. Sometimes if I want to experiment, what I will do is I will start Jenkins and set the Jenkins home from the command line. So here if I do Java, set the system property Jenkins home, set it with the -d, so -d Jenkins home equals, and then I set the folder that I want to be the Jenkins home, which in this case is going to be /home in my main Jenkins folder. And if I do all that with the setup, then in c:/Jenkins you can see that it's created a home directory, which is another configuration of Jenkins. And if I refresh Jenkins now, it's a different thing, so I need to log in. You can see that this is a completely clean one. This is what I used when I was configuring it in the earlier example video of how to set up and configure Jenkins. So if you need to, you can change the Jenkins home and have a different configuration for your Jenkins. Periodically I do that when I'm experimenting, periodically I'll do that when I'm backing things up, but it's worth knowing that that capability is there so you can use it if you have to. Previous versions of this course used Subversion for the version control system and all the continuous integration examples. So I redid all the continuous integration videos to use Git. But there were two sections which I didn't change at all. And you're about to see one of them. This was the cross-browser testing section. And what this section shows are the changes that I had to make to the course source code when running them cross-browser under continuous integration. So given that the course source code is bigger, has more edge cases, there's a lot more workarounds. So this shows the different kind of things I had to do to fix a test running on Firefox or Chrome or IE. And it might be worth going through just to see the kind of things I had to do. But this is an optional section. I mean, you'll notice some changes between the source code in the course and the source code in the CI code because I made changes to get them running on HtmlUnit, because HtmlUnit doesn't handle get text. So all the interrogation tests that were asserting against text on the page have been changed to assert against IDs or name attributes. That's one of the simple changes that I had to make in order to get it working cross-browser in continuous integration. These videos show more detailed changes on the other browsers. So I'm just going to show you some of the things that I learned when running these things against Firefox. I mean, even though most of the tests have been developed against Firefox, trying to figure out how to put this into continuous integration led to some slightly different changes that I had to make. So some of the tests for our purposes failed. That was perfectly acceptable when running through the tutorial to have tests that fail. That was their purpose. But when I put them in continuous integration, having them fail is not a good thing because that will fail the build. That will cause it to have a problem. If I know that the test is going to fail, then I want to make that one of the expected conditions in that test. So let me show you an example. So my failing WebDriver wait test. So this one fails. This one was intended to fail. Now what we did during the tutorial was just @ignore it, but we can do better than that. To make it run in part of continuous integration, I can say it's a test and it's expected that it will throw a no such element exception. This is the JUnit way of saying we expect an exception to be thrown. Now there are other ways of doing this. I can try catch blocks around inside the test and then assert on different combinations of exceptions, and if I don't get them, throw an assert. For this one, because a single exception is being thrown, putting it in as an expected condition up here is a perfectly valid thing to do as part of continuous integration. If at any point in time this test does fail in continuous integration, it means that something has changed, because this is my assumption about what the test will do.
This is my expected condition that we're checking. It is expected that this will throw an exception. So this is one of the constructs that I used in order to move the failing tests into continuous integration. Now the manipulate exercises submit form test. I had to make changes to this because running this test under continuous integration showed this to be intermittent. So this is the previous line we had. Assert equals, expected the form to be processed, process form details, driver.getTitle. In order to make this less dependent on timing, I've put it in as a WebDriver wait. So now I send the keys, then wait until the title is this before doing any of the follow-on checks. Previously we just did send the keys, then assert that the title was this. Clearly there's the potential for a synchronization issue there, and that's what happened under continuous integration, because what you'll find is that when the tests are running in the IDE, they'll run more slowly than they run under continuous integration. They'll run more consistently in the IDE than they will under continuous integration, because you don't know what else is happening on the machine. You don't even necessarily know what order they're going to work in. So running under continuous integration really exposes the synchronization holes that you've left in your test. And the use WebDriver wait fluently test is also a synchronization issue within the test pack. Now this is a very time dependent test. Java isn't necessarily great for the waiting and the timeouts within the times that we're doing here. So what this test does is it waits for 5 seconds and checks that the time now is greater than the 5 second mark. Now sometimes it's dead on 5 seconds and this test fails. Really, I should make this greater than or equals to make the test pass more readily. Hopefully the timeout should never come below 5 seconds, but if it does, I've added a system out of the calculated time to make sure that when I run the test as part of continuous integration, I have some sort of logging in the console that shows me why that test has failed. So timing can be an issue because the times will run differently under the IDE and the continuous integration. But you can see here this was just an assumption, worked fine in the IDE. In CI it actually runs faster, so sometimes we don't hit this particular assert correctly. And I had to make some changes in the test to support Chrome. So we had this test for JavaScript runs as an anonymous function, but we can leave some behind. Now this was initially written on Firefox, and it works perfectly fine on Firefox. What we do is we use the execute script to create an alert and then check for the presence of the alert as we go through. Now the unfortunate thing is this is the only browser that this test works well on, and because all I'm doing is demonstrating the use of execute script, the alert part is not actually important. So I've created a cross-browser problem by the JavaScript that I'm using, not because of any of the API issues, just because the scripts, that the drivers does not expect you in your test to be generating alerts. There's absolutely no point to that. That was the example we did, and it causes issues on the different browsers. It causes issues, i.e. completely blocks. Chrome throws an unhandled alert exception, and Opera just hates alerts, just completely. So I've left this test as it is, and basically said, only run this test if it's on Firefox. I haven't bothered trying to fail the test if it's on different browsers, because we know it will fail. And what I've done is change the test so that instead of creating an alert, what I do is I write some JavaScript that changes the title. So instead of doing an alert triggered by WebDriver, I simply have some script that changes the title to a particular value, then assert that the title has changed. And this is the same with, I create a function which changes the title instead of doing an alert. So I had to actually change the example that I'm using in the test to allow it to work cross-browser. So if you tried that earlier on in the course and saw problems cross-browser, well done to you for spotting it early. And the test needed to change in order to make it cross-browser. I also found that Chrome hates the frames examples that I've been using. The frame set pages, Chrome just hates that stuff. So the frame tests are not running on Chrome. That's not a driver issue. There are instances where Chrome works with frames, but the code that I've got in the HTML, the ChromeDriver does not handle particularly well. But Firefox does, so that the API for frames is demonstrated throughout the course. It's just not particularly cross-browser, and that's the application under test, not the actual WebDriver API. So I'm not going to change it for that reason. But really, Chrome and Firefox work fairly well. They're almost the same. The tests that failed on Chrome as opposed to Firefox were mainly frame related, you can see here, and some of the window tests failed on Chrome rather than Firefox. So I don't run them as a It was mainly the switching to part because it's using frames. So it's just the frame part that doesn't work particularly well in Chrome for these examples, whereas everything else seems pretty much okay. Now for most production test packs, people ignore Opera. I quite like Opera as a browser, and Opera is very, very popular on the Android devices now. But I had to make more changes for the Opera browser than I expected. Now, some of it is known, like the Opera driver does not support alerts. It just doesn't do it. Opera does not support a lot of window manipulation. It doesn't do it. These are known things in the driver. Presumably in later driver releases, these things will be fixed. There were a few things that I didn't necessarily expect though, so let's have a look through some of those. So Opera does not support the file upload, so we couldn't do that test. The Opera key presses, so I had to make changes here for Opera, and you can see the way that I've done it. Normally we would make the changes in the page abstraction models. I'm having to make the changes in the tests to try and keep these tests as backwardly compatible with what we explained in the early parts of the tutorial as much as possible. So what I'm doing is, I know that the send keys for submitting a form does not work in Chrome or Opera. So what I've chosen to do is send the key, wait until the title is the correct title. I'm expecting this wait to fail on Chrome and Opera. If it passes, then it means that this functionality is now supported. So I then throw another runtime exception afterwards, depending on each of these browsers, to alert me that the driver has changed, because I will be running these tests against the updated drivers and against the updated WebDriver as they get released to make sure that this course is still valid. So instead of just trying and catching it and assuming that it always fails, I have put some checks in to see if it still continues to fail. Now normally you would either exclude the test completely from your test suites for particular browsers, code around it in your abstraction layers, because really this is very specific. This isn't a test of the application, because I know the application works. This is basically saying the driver does not submit the form when I do send keys. But if I use it in the browser itself, it does work. And really, the test is not can I submit it with the keys, it's more can I submit the form. So my abstraction there would have a form that has a method to submit it, and that will make it cross-browser. The functionality of the application can be tested cross-browser. Because we're working down at the API level here, we're starting to see browser tests that need to be excluded from each of those browsers. This isn't the way that you'll normally work in practice. Okay, so in the manipulate what happens if test. Now this is another API specific set of examples, because the drivers work differently. So can I clear a checkbox? Well, yes, we can. In some browsers, but not others. So you can see here that I try and do a checkbox clear. On some of the drivers, it throws an exception. Opera does not throw an exception, but it does not clear the checkbox either. So you can see what this test does. It basically says, make sure it's selected, then try and clear it, then I'm expecting a WebDriver exception. However, if it does clear it, I'm expecting it to be Opera, but I'm not expecting the checkbox to actually be cleared. So whilst Opera says it's cleared it, it doesn't actually do it. It just doesn't throw an exception on these methods. And this is really the driver not working the same way as the other drivers, because the specification for the drivers doesn't say it has to throw an exception at this point, because a lot of it are runtime based exceptions rather than checked exceptions that have to be declared at compile time. So the drivers can implement them slightly differently. But most people will not notice this level of difference in the browsers. It's only because we're going into depth in the API that we actually see these differences. Now, one thing I didn't expect was the refresh on Opera. So some of the tests actually relied on a refresh. So most of the drivers, when I do a refresh, they block until the refresh has happened. That doesn't happen with the Opera driver. I think the Opera driver may have issues with its refresh functionality, because not only does it not block, but sometimes it doesn't refresh the cookies. There's a whole bunch of things that the Opera driver does not do well under refresh that caused me issues as I was looking at these tests. So my suggestion to you is that you don't use the refresh functionality a lot in the real world if you want to maintain cross-browser compatibility, or if you do, you will need to code around it for the different browsers in your page objects. So you can see here that what I had to do was, previously I just did a refresh, then checked the title. Can't do that anymore, right? Here I have to, and this is purely for Opera, wait until the title is no longer what it was. So I've created a new wait in here. Title is no longer a new expected condition, just for the Opera synchronization. Now I was bitten by this refresh in a couple of places in the API, but that was an important thing to learn that I did not know. The Opera refresh does not work particularly well. Now in the cookies, again, the Opera driver does something slightly different for the cookies than I expected. And it was related to the way that the cookies are created. So these are the cookie tests that we had. These don't work on Opera. So I've created some tests that do work on Opera so we can see the difference. Now the thing about Opera is that when you query on the cookie, the date that comes back is not the correct date, in the sense that you cannot create a cookie in Opera if the expiry that you've put in expires in the past. Now, if the cookie itself does not expire, when you get the expiry date from the cookie, it is completely invalid and incorrect. So let's have a look and see what happens. So you can see here that in order to set the cookie, in all the other drivers, all I do is get the cookie from the actual browser, then use the values that are on that cookie, so including the get expiry. Now, the get expiry on Opera didn't work effectively. So I'm working around it by throwing in a null in here rather than the value from the cookie, because the value from the cookie was coming back in the past. So if I did a get expire on that cookie, I was getting something for like 1972. And I cannot create a cookie with an expiry date in the past on Opera. So this whole cookie setup was failing on Opera. So to work around that, I just simply don't put in the cookie get expiry. So that was an interesting thing I did not know or expect. I expected this, that when I get a cookie from the browser, get the expiry from it, I could create a new cookie with that expiry date. Not so in Opera. So there's a bug there on the get expiry that I'm sure will get fixed in the future. And most of the problems that I had with Opera were related to refresh, the cookies, driver functionality that does not and is not supposed to work yet, like the alerts and window handling. There was some intermittency around the JavaScript execution, but I didn't view that as seriously enough that I had to work on it. I did view the refresh as something that was my fault, so I had to synchronize around that. The cookies I wanted to figure out how to fix, so I've put in code that demonstrates how to do that. But Opera was not as fully featured as the Chrome and Firefox drivers. So IE had some issues. With IE, I found that the get title replacement exercise, let me show you. Now, IE did most of this fine. What it didn't like was when I tried to access things like this, the head in the middle. I think the CSS selector, it just doesn't like, I think it's the root, I think it's the HTML part that IE does not like in the CSS selector. So it's quite comfortable going to the head and getting the title. What it doesn't like is if you try and use the HTML part. It's the same here. So here where I'm trying to use HTML with the title anywhere under HTML, IE does not like this. Same where I say I want you to go HTML, then head, then title, IE doesn't like this. So I think that the CSS selector in IE does not like using the root from HTML. Also, the creating an alert from JavaScript blocks IE completely, and it just sits there hanging there for hours. So just don't do that when you're using IE. You won't, but it's purely for our test that happened. The user interaction tests, user interactions work on IE, but whilst the user interaction page works fine when you use it in IE, I know that it works, I can do it manually. Trying to use the user interaction page that we use with the blocks moving about does not work well on the driver in these tests. So I've skipped those tests from running under IE. Now I don't really worry about IE too much with WebDriver. I know that a lot of people want to see all their tests running under IE. The simple fact is, WebDriver is only as good as the drivers that it has. And the IE driver, the guys that create that go through an enormous amount of pain to get that driver working on Windows, because IE locks everything down. It has to run completely with native events. It doesn't have a good interface into IE itself. I also found that the alert handling on the IE doesn't work very well, because the IE alert boxes show a script prompt : at the top instead of, the other browsers don't do that. And then when the IE driver calls the get text from the alert, it gets script prompt : rather than the actual text in the alert box. So there's a whole bunch of nuances around the IE driver, and I tend not to worry about them too much, because what I'm concerned about is making sure that the application is functional under most circumstances. If I can't get it working on particular browsers, very often I would just drop that test, because it's more work to try and automate it when it's not actually a problem. It works on that browser, we can double check it manually. You have to make these risk decisions as you go through. If I can get it working across most browsers, I'm pretty happy. Which is why I've taken this fairly extreme form of just dropping the test down into different suites. And you can see what works across the different browsers and what doesn't by looking through the suites that I've got. You can see that I basically went through the order of Firefox, then Chrome, then Opera, then IE, which is why some of the tests fail on Chrome and Opera and IE. So you can see that Firefox is the most featured driver. There's nothing here that says fails on Firefox. You can see some that only fail on IE. That's user interaction ones. Couldn't get those working through IE on the page with the driver. There's some that failed only on Opera, and most of these are known in the driver classes, but they work on the other browsers. You can see there's a Firefox only suite, but that's only because Firefox is encoded in these as the start part. So most of the tests do actually run cross-browser under a continuous integration environment, which is quite hard to do. So this is actually a pretty good example of cross-browser tests. Now the other thing I have to change in the code to allow us to work under continuous integration is how we configure the driver to use. Because you can see that normally in the driver we just set it up as the default. I say use this driver, pick Chrome. That all the tests will now run under Chrome or Firefox. We've seen that. What I really want to do is give me the option of changing that if I want to, but I want to configure it outside the driver class itself. Now, this is a singleton, so I need to set this completely outside. So you can see here I have the option to set the browser from within the tests. So in my tests I can say driver.set to a particular browser. Great. What I really want is when I do driver get, if we haven't set a driver, that it knows how to go and get it. So the way that I'm doing that is I am using a system property. So I'm using a system property called selenium2basics.webdriver. Now I can set that up as an environment property, but the way that I do this from the command line and continuous integration is I will pass this in as a -d command. So I would say something like maven space test space -d selenium2basics.webdriver equals Firefox, and I will configure the browser that we're going to use from the command line. So this is what this code here does. This basically says if I haven't set up a default here, then have we got a property set up? So it looks for Selenium2 WebDriver Basics. If it can't find that property and we didn't configure a browser there, then it defaults to Firefox. If it can find something set up in that property, what it does is it tries to match it with our known set of browsers that we allow the driver to use. So if it's Firefox, we use Firefox. If it's Chrome, I use Google Chrome, IE. You can see the switch statement down here. And if it is a value that I haven't coded for, I throw a runtime exception. Then you can see we know which. That's the only change that I've had to make in order to allow the test to be configurable from the command line. Because everything else is previously with a singleton. If we haven't instantiated the driver yet, then instantiate it. So all this code remains unchanged. So apart from, because I know that it's going to go under continuous integration, I want the ability to configure the location of the drivers a little bit better. So I've changed the way that the driver is found. So it sets the driver property if necessary. This can be set outside. So I can set a webdriver.ie.driver as a system property, and the code will pick this up. Or I can set it as a relative path, and this is the way that the driver was working. Remember, I set up a tools folder at the root level. The other thing I do is I allow an absolute value. So in my test, I'm coding an absolute value so that I can have it run on a continuous integration server and just add the drivers into WebDrivers or IE driver folder or ChromeDriver folder. Or I can completely set it from the command line. So I've added this extra method, set driver property if necessary, and all it does is say, does this property exist? If it doesn't, then try and find the driver in the relative location, because that's what it originally did. If it can't find that, then try and find it in the absolute location. So that is just a little additional code that I wrote in order to allow me to position the driver in different places. Other than that, the driver class is pretty much the same. I think those were the only two things I changed. I didn't necessarily need to change this one, by the way. I could have taken out this entire code whatsoever and used the system property directly, because that's the way that WebDriver expects to work. What I'm doing is, just in case I haven't configured it to use our driver in part of the system properties, then I can use relative paths or absolute paths to find it, just to make my tests a little bit easier. Now remember, this driver class is not intended to be a great example of a production-ready driver, although it can be used in production and we can set up the browser from the command line, because it doesn't really support parallelism very well. If you want to split the tests into parallel runs, this particular driver class, as it's currently written, will not support that without change. But the construction of the driver abstraction for how you control your browsers is going to be completely context dependent on your automation requirements and the environment that you're working in. So this is a fairly good example of a very flexible driver that's a singleton that reuses the drivers over time, and is a good thing for you to build on for your production environment. But at the point that you need to do parallelism, you might have to become more flexible, possibly use the grid out the box and start working with grid, because that supports parallelism, and then not necessarily worry about which particular driver that you're using. But it's a fairly good example to get started with. And you can see that it didn't take much in order to configure it from the outside. Just the addition of a single property, then checking for the property and the defaults and setting up the browser for using that particular property that's been set. So we've done all the code changes required for getting the code ready to run under continuous integration. We've created the suites, we've changed the driver to allow us to configure the driver from the command line. The only other thing we have to do is change the POM file. And you can see that what we've had to do is create a set of profiles. So in the POM file, when you look at it, you'll see that I've created a set of profiles. So under the profiles section, this is a new profile section, I've created a profile for any browser tests, and I've made this active by default. None of the other profiles have an activation section in them. They all have an ID and they all have a build profile, but the only one that has an activation is the any browser tests. Now I'm not going to explain profiles in extreme detail, because again, that's standard Maven functionality and you can look it up on the web. I am again making this very simple and showing you the simplest thing you can do to get these tests running. I haven't even tried to do anything clever with these profiles. I basically said a profile for any browser, a profile to run the tests that pass under Firefox, run the tests that pass under IE, run the tests that pass under Chrome, and then Opera, and then some failing tests. So I've got a profile for only run those that fail under Opera. So I'm creating this very, very simple. There's some duplication in here. But you can see that what I've done is each of these profiles has a build section, which with a plugin section, and there's only one plugin in use, and that's the Maven Surefire plugin. Again, you can look this up on the web, but this is the one that really runs the JUnit tests. So for each of these Surefire plugins, I've created a configuration. And the configuration, all it does is have a set of includes. And these includes are the suites that it's going to run. Because these suites partition out the tests, So there's an all browser suite test. For Firefox, it runs the all browser suite test and all those tests that fail on Chrome and Opera and IE, and all those tests that run on fail on Chrome and Opera and the Firefox only suite. And you can get a feel for what I'm doing here. I've created a profile with an ID. Now what this means is from the command line, you're used to running maven test. Maven test now will pick up the default profile, which is the any browser test profile. If I put in the -p parameter, so if I say maven test -p, then the profile ID, I can run a profile. So I can do maven test -p any browser tests, and it will run this one. Don't have to do that because maven test will run it. If I do maven test -p Firefox tests, it will run this profile, which will bring in the all browser suite test and the fail on Chrome and Opera and IE suite test and the fail on Chrome and Opera suite test. Now the way that I control the browser from the command line is with the -d parameter to set up an environment variable. I'll say -d selenium2 basics.webdriver equals Opera. So I can do maven test, which will pick up the any browser tests and run it on Opera. Or I can say maven test -p Opera tests and run it on Opera. So I can pass in any of those values that you saw in the driver and run it against any profile. And when we come to move this into continuous integration, because the first thing we do is change it in the profile, then check that all these things run from the command line. Because all that we're going to do when we put it into continuous integration is run this command. So in order for me to run the Opera tests, this is the command that I will put into continuous integration. And when you look through the POM file, you see that this is pretty simple. I have a profile for each of the configurations I want, then I include the suites that I want to run. And that's it. So I'm going to let you have a look at that and play around with it. Do look up profiles on the web and try and understand them a bit more. But that's it. That's the only change that I made. It's very, very simple. So this is another set of older videos. These are still relevant, even though they use Subversion. They show a slightly different way of configuring Jenkins, because I don't think I used the Maven integration plugin when configuring these parts of the project. They do describe some ways of scheduling Jenkins for different times. It shows the examples in Subversion if you're interested in that. And there's a discussion of test intermittency and how we go about dealing with that as part of the build process, which is quite real world. So they're slightly older videos, but they are still worth watching through. Okay, so now we've made all the changes that we need into the POM file and into the code. We've checked everything in. It's time to set up a Jenkins job. Now remember, a Jenkins job is what we add to run these different tests. So I'm going to create a Maven project. I'm going to call it test Maven job. I already have all these jobs set up, so I'm going to delete this one later on. Now I'm setting up as a Maven job because that will automatically configure it to pull in the test results and things like that. So I want to hook into Subversion, and we are putting it onto xpdev. So under Selenium Basics trunk code, this is the link that you get when you sign up. We want to use an SVN update as much as possible. I could set it up to always do a fresh copy. Because we're using Maven, we don't have a lot in SVN, but I'll do an SVN update. It'll make it even faster. I have my build trigger. I could do the build trigger so that it polls the source code management system. You see here, if I look in the question mark, the timing that I can set up. So I can say every 15 minutes, regardless of what hour, regardless of which day of the month, regardless of which month, regardless of which day of the week, I can build this or check the source code management system every 15 minutes and build when it changes. That's excessive for the code base that we're using. I could also set it up to build periodically. So I can say at 15 minutes past 1 o'clock in the morning. So I could set up a nightly build quite easily by doing this. Now I'm going to leave this with no build trigger. I'm just going to do it manually. So the root of the pom is pom.xml. Now I also want to set this up to use the configuration that we have. So I want to say clean test, and I want to do a -p Firefox tests, because that's the profile that's been set up that I'm going to run. I'm going to run Firefox tests, and I'm going to configure it using the Selenium 2 basics.WebDriver property, which I pass in with the -d option to use Firefox. I set these up to post step to do anything, although I'm not really doing any post steps. And remember, whenever you make any changes, you either have to save or apply it. So if I do apply, you can see that it saved it and I'm still editing. If I do save, I come out and stop the edit. So now that I've got that configured, I can now build the project. So build is now scheduled. You see it here in the build history here. So this is the one that's running. If I go up to the root folder, you can see that it's building the test maven job. Now if I hover over that, you can see all the different options in there, or I can jump directly down. And if I go over the build history, you can see that I can actually look at the console output. So you can see I can watch the job running. It's done all the checkouts. Now it's running the tests. It started building it. It's compiling it. Now it's starting to run the tests. Now I'm going to leave this running because it's going to run in Firefox. This will take a little while. So when we come back, you'll see this in time-lapse mode. And then we'll have a look at the output for running this. Okay, so that's finished, and we have a test failure. Well, that's good because that allows us to see what that looks like as part of the build and how we see this reporting. So if I scroll back up, you can see all the system output that happened as the test was running. You can see that we started with the cleaning out local directory, then doing a checkout of the code base. Then you can see the command line that was used to start it. Here it is here. Maven clean test -p Firefox test -d blah blah blah. And then all the system output that happened as the test was running. So now, if I jump up here into the Maven test job, you see the latest test result. And I can drop down at these and see the failing tests. Now, each one of these tests runs when the test is run from the IDE. So this is an intermittency, and this is an intermittency that shows up when the test is run in continuous integration. If I spent more time on this, I could probably remove this intermittency, because the intermittency is related to the way that the test is written, and is most likely a synchronization problem. Chances are, if your tests are running from the IDE, but failing in continuous integration, there'll be some sort of synchronization issue. Normally we fix those through the use of abstraction layers and page objects. And because a lot of these tests are designed to illustrate the use of the API, they don't have as much rigor wrapped around them to immunize them against this kind of synchronization issue. So I'll show you the history in the previous test, but this is some sort of synchronization problem. So as I jump down into the failed test, you can see the stack trace that happens. Now that allows me to see the line that the failures happen on, so I can go back into the test code, have a look in this custom expected conditions example test.java, look on line 30, and I'll start seeing what kind of problems that I've got in this test. It looks like it then moves through into an expected condition over here on line 62 and line 47, where something is not being kept up to date. There's a stale reference, the page is changed underneath. It's certainly a synchronization problem. But this is all recorded in Jenkins. All of this is reported in Jenkins. I can see the build. I can see the test results. I can see what ran. I can see what failures we have. This is the most low-tech and easiest way of getting visibility into our test runs. Now, if I want to remove intermittency, what I do is I set up the job and I have it run consistently, or every half hour, every hour, while nothing else is changing, so that it exposes over the time that it's running the test, the intermittency in the test. Now you can see in the Jenkins builds that I've got, a lot of them are intermittent. If I drop down into this Firefox pass job, this does the same thing as what we just saw. And you can see that for the period of a couple of days, I let this run every hour. So here we have a pass. Nothing changed. Then we have an intermittent failure, an intermittent failure, intermittent failure, intermittent failure. Pass, 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 pass. Intermittent failure. So the intermittency is exposed by running the test consistently against the same code base on a regular basis. This is how we deal with intermittency. But for now, you saw how easy it was to create a job in Jenkins. So when we come back, I'll look at some of the other jobs that I've set up. And if you use that Maven job to start it up, you don't even need to do any additional configuration to pull in the unit test results. So let me just walk you through what I have configured in Jenkins for my local use to help me make sure that the test code that's been written for this tutorial runs against all the different versions of WebDriver. So you can see here I have two top level jobs, a failing test build and a passing test build. Now what the passing test one does is it runs all of my passing test builds. So this Selenium 2 Basics passing Chrome, this is all the tests that are supposed to pass in Chrome. This pass Firefox, all the tests are supposed to pass in Firefox. Same for IE, same for Opera. This passing test job runs all of those. So if I have a look in here and configure this, you can see that what this does is it has on its own it does nothing. This job does nothing. But after this job, what it does is it says, build these other projects, the Selenium 2 Basics Pass Firefox, Selenium 2 Basics Pass IE. So this is a comma delimited list of those other job names, even if the build fails, no matter what. And I can say, build this periodically. So I can say every hour. So every hour, so I'm going to say every minute of every hour. So at the first minute of every hour on any day, blah, 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 blah. So this will run pretty much on the hour and run all 4 of the passing jobs. And that's how I created this sort of consistent run all the passing jobs for intermittency. So that's the passing test job. Now that's really just a grouping job for my convenience. I've got the same thing for failing tests. If I want to run all the failing tests, that's what this one does. It runs the fail Opera, fail IE, fail Chrome. Now the passing jobs themselves are exactly the same as you saw in the configuration for the test job. So if I do a configure here, you see that I have it set up to pull, to go into Subversion, do an SVN update, run a clean test on the main POM, Firefox tests with the browser as Firefox, run regardless of build result. And that's the same for all of them, and the only thing that's different in the configuration is the suite, so the Chrome tests, and the browser. Remember, these Chrome tests are set up in the POM. So you can see that my profile, so my Firefox tests runs the all browser suite, the fail on Chrome and Opera, the fail on Chrome. All of this stuff is configured at a top level through the IDE so that I can run it and configure it nice and easily from Jenkins. That's pretty much it. There's not a lot more to this in Jenkins. So walk through of what we've got. We can have a look at the workspace. This is the checked out code and the compiled versions. Now I can wipe this out and it will force it to do a clean subversion checkout by default. I can build it now. I can configure the project to be disabled. I can disable this build so that as part of the full pass, it will do the IE and Chrome, and so IE and Firefox and Opera, but skip the Chrome one because the Chrome one would be disabled. So I'll tell you how I use this. So when a new version of WebDriver comes out, I will run the passing tests and see if anything has changed, whether it becomes more intermittent or less. Remember, I am living with intermittency in these tests at the moment because the tests themselves are not designed to be completely stable across all browsers. They haven't got all the synchronization routines in. Now I may gradually change that over time, but it's not something I'm worried about at the moment. What I will look for when I run the test is to see if any major new set of failures is introduced by a new WebDriver. I will run the failing tests and see if there are any changes, because if the failing tests are supposed to be very consistent. So if some of them start passing, it may mean that the driver now has additional functionality into it and that some of the tests can move into the passing test suite. When you start putting your tests together for your production code bases, you may want to separate out failing tests from passing tests. You may want to have some slow running tests, fast running tests, and split them up. You can do that through suites or profiles, however you choose to do it. Because you've seen 2 mechanisms now for controlling the tests and how to use them in conjunction with each other. So I just want to spend a little bit of time exploring intermittency. In the real world, intermittency is bad. It is one of the worst things that can happen to your test code base, because what it means is that people ignore the build. If you have something like this, where it runs most of the time, fails, runs, people will ignore the failures. Now these failures could be important. This might mean that something changed in the code base, then someone made a change that fixed it up here. If we completely ignore it, then there's no point running the test against it. We're not getting the information we want. What we should be seeing in a production code base is a sea of blue, and we should stamp on every failure that comes through and understand it, because it should either come from a code problem, in which case it's a valid failure and our test has revealed it, or it's a failure in the way that we've written the test, in which case we have to fix it, or it's a failure in our abstraction layers, in which case again we have to fix it. Now, in the tests that we have here, I'm less worried. I'm taking a different view of it here because my aim is to explore the API, write tests that cover the API, and try and get them working across most of the browsers most of the time. But if the test itself is intermittent, gradually I will fix it, but I'm not as concerned as you should be in the real world with your production code bases. So the trick to identifying intermittency is to run your tests when nothing else is changing. So if it's feasible for you to set up an environment, if you think you have intermittent tests, if you can set up an environment that doesn't change and just run your tests against it, so every time the test run stops, it immediately kicks off another run, and immediately kicks off another run, or runs every half an hour because your tests only take 20 minutes to run. If you can do that, then you will expose the intermittency as I have done here, because you can see that every hour the test ran and nothing changed in the code base at all. This is just intermittency in the tests. I can click through into these and see whether the tests that fail are consistent. That's a consistent intermittency between those two results. That test is no longer here, but the tests that do show up here are likely to be the ones that are intermittent that I need to drop down into and fix to see what's going on. So I can see the same names coming in again and again. So there is something in the synchronization in these things for intermittency. We already explored the wait 5 seconds test as to what was intermittent in there. Now you can see that the Firefox one is pretty good. The test, if it fails, it's only got one failure or two failures each time. It's the same tests most of the time. If this runs and starts showing 20 failures or 10 failures, I will suspect that it's not a problem with the tests, it's a problem with the driver, or the API has changed, or the driver has changed in some way, or the browser has been upgraded and I didn't notice. That's what these tests are designed to tell me. Your tests should consistently pass, should consistently go green or blue as they do in Jenkins here, and you should investigate and stamp out every intermittency, because if you don't, what will happen is you will keep building on top of this. You'll eventually get to the point where you have several hundred tests, and the amount of work that you will view it as trying to fix the intermittency, because chances are the intermittency is buried deep in your abstraction layer and comes up when you least expect it, and because that part of the abstraction layer is used across 300 tests, you suddenly have all 300 tests being intermittent when it is a single line in your abstraction layer that needs to fix. You need to stamp out on it as quickly as you can when you build up the tests, and do not compromise on that in your production environment. So the reason I'm stressing this is because I'm conscious that I don't want these tests to act as a bad example for you. These tests are intermittent because the risk profile that they are designed to cover is different from your production code. The risk profile here is when WebDriver changes, does the majority of the exercises still work? Do I need to go back and change them? On yours it's different. Every single one of your tests should pass. If you're expecting a failure, you will code for that by either putting a try-catch block round or putting the expected equals in there. Your tests should not be intermittent.
When we start using a grid setup, we want to make our test configuration as flexible as we can. In this set of lectures, I'm going to show you some changes I made to the driver class to help me with that. Sometimes we want to define the grid configuration and browser details in the code when we're experimenting, when we're trying things out, when we're debugging. We want to make fast changes just to get things configured the way we want. Sometimes we want the
configuration to span our entire environment. So we use the environment variables. You've seen me do that in the earlier lectures. Sometimes we might want to use property files, or we might want to add them in as system properties using the -d commands at the command line. Obvious example is the -d skip tests, but that's how you've seen me configure the browser that we're using in the tests from the command line. Now I don't really mind which one we choose, but I do want the flexibility when I'm handling it. What I do not want is the code or the chosen method to limit my flexibility in how I test or how I go about using the code. So I'm going to show you a simple approach that I've used before, and it's the approach that I've amended the code to use. So the change is I've chosen to have default values and environment variables and properties. All of them allow me to configure what we're doing. That way I can amend the code for quick fixes using the default values. I can configure the system environment variables because then I can have global variables for my particular system that I'm working on. I might do that on the CI or on the local environment. And I'm going to allow myself to use property variables. These are local to the JVM that I'm running on, and you've seen that we can set those in the code, or we can pass those into the JVM as -d parameters. And I'm going to use the following priorities: properties, then environment variables, then defaults. That way, properties passed into the JVM can override environment variables, which helps with CI config and debug execution. The environment variables come next. These are typically slow to change, because if we have to change those, then we have to restart the IDE or restart the command line that we're using to pick up the new values. And if I'm debugging or experimenting, then that can slow me down, and that can really bite when I'm trying to work and debug. So I don't want to make that my only config option. And if I haven't set any properties or environment variables, I still want to run code, and that's where the defaults come in. So I'll quickly show you the changes that I've made to the driver class. The first major change is down here. So you can see previously everything was coming in through a property. So we got the property for the browser property name, and we had a default. Now instead of using the system.get property, I'm using a method that I've created called getProperty or env, which takes the same arguments, a property name and a default. And that's pretty much it. So let's look at the method code itself. Now there's nothing magic here. All this really does is check to see if there's a property. If there's not, check to see if there's an environment. If there's not, then it uses a default. That's pretty much it. However, this method is static because it's used by the static get method on the driver class. And I've made it private because this is only used by the driver. Now if I want to use this code anywhere else, and I might, because really this doesn't have anything specific to do with the driver. This is a method which reads from a property or an environment variable, or it gives you a default. Now none of that is driver specific. This could just as easily be in a config class, but I've added it to the driver because that is where we're using it, and to cut down on the number of code changes that I made to this example code. I've made it private to remove the temptation to use it in different places, i.e. to control configuration and tests, things like that. If you do want to reuse it, then take it out of the driver class and create a new class for it. Otherwise, you start to make the driver responsible for more than it needs to be, and you'll increase the maintenance overhead. And this is what I see happening live. People stick methods in to classes because that's where they want to use it from. Then they want to reuse it somewhere else, so they just make it public, and then you start to have code dependent on other code that it shouldn't be dependent on. Really, if we want to reuse this, it needs to go in a config class. So looking at the code, you can see all we do is check for a property. If it exists, use it. If it doesn't exist, then check for an environment variable. If that exists, use it. If it doesn't exist, then use the default. And I've added system outs to show up in the console log what environments we run the @test code against. One useful thing about this is that getProperty supports defaults, but getEnv doesn't. So now we have a way of having default values even if we're using environment variables. One bad thing about this is that it conflates properties and environment variables, essentially treating them the same, which they aren't. So we can't have a property and an environment variable named the same but do different things. So there's trade-offs when we write this code, but this seemed like a simple way of making the changes. Now if I wanted to use property files, I could just as easily add some property file handling in here to go and look in the property file. If it's not in the property file, then go and look in the environment variables or whichever other priority order I wanted. Previously, I showed you the SauceLabs code and config, and we created a specific SauceLabs browser to handle that. Really, that was just a quick hack to get things working. Now, the whole point of the grid is that it is remote and highly configurable. So I've created a new browser type in driver called grid, and then have new properties or environment variable names to configure the browser name, the browser version, the platform, and the grid URL. You can see that code here. Again, this is kind of hacky, but good enough. You can see that I've got defaults for the browser. You can see that I've got defaults for the hub, acting as a local host. You can see that I do not add capabilities when they're not present, because the only capability that needs to be present is the browser name. Everything else has defaults in grid itself. So I don't add a capability for the browser version or the platform unless that's specifically added. You can see that I'm using the platform enum from Selenium itself so that we don't add any issues in there, and Selenium will throw issues if we try and use strings that are not present. Again, it's pretty simple. It looks very like the SauceLabs code, which is what you'd expect. It's just that little bit more configurable. And again, I'm just trying to illustrate an example rather than tell you that this is how you do it in the real world. This will work for many situations, but you may need additional flexibility, or you might need to pass in more capabilities. Then you can extend this code or write something else that meets your needs. But for my purposes and for demonstrating the flexibility on the grid, this code is good enough. I can configure this to use SauceLabs, a local grid, BrowserStack. I can set it up to run on Mac or Windows. I can choose different browsers and different versions, and that's good enough for what I need to do here. And this is a simple example for how to configure your tests using the same method within the CI using the properties. So all I do, here's Jenkins running, here's the job to run the code on SauceLabs using Windows. Let me configure this. So you can see here all this is doing, you've seen all this before, it's picking up the code from the repository, it's using svn update, then I'm using the pom.xml, and I'm using the goals and options so that I'm saying I want to do a maven test and I want to use it with these properties. So -d for the Selenium grid, -d to set the WebDriver URL on the grid to be the SauceLabs one. Choose Firefox, choose browser version 39 and the WebDriver platform on Windows 7. All of that within the Jenkins build, nice and easy, there's nothing hard there. If I do let me configure this. Let's get SauceLabs up next to it. Let's do a build now. Build starting, it's checked everything out, it's starting to run. We should see this job kick off in SauceLabs. There we go. So now that test is running from Jenkins in SauceLabs after being configured using the properties, using the -d at the command line. One of the aims is to run this from the command line, so I'm going to do that just by using the -d
parameters. So basically I say -d, then the parameter name, then the equals, then the value. You've seen that before with the Selenium 2 basics.webdriver, which I use to control the browser. Now I've added a few more: the WebDriver grid URL, the WebDriver grid browser, the WebDriver grid browser version, and the WebDriver grid browser platform. You can see that the platform for Windows 7, because it has a space in the name, I put quotes around it. So this is what the command line looks like. That's relatively horrible to use, but most of the time you won't be running it from the command line like this. You will be putting this kind of statement into your CI process, but this gives us flexibility to override everything at the command line. So if I give you a quick example of that, this is the command line I'm putting in, maven test, followed by all the parameters I need. And you can see that I've added my SauceLabs URL in there. That access code will immediately be changed after this lecture recording, so don't try that one. But I'm putting this in here so you can see this running. That will start up my tests. Let me get a SauceLabs window across here. So you can see that the driver has told us what parameters it's using. We're doing grid, we're doing Firefox, version 39 on Windows 7 in SauceLabs. There's the URL, and the test has started in SauceLabs here. And it's working through the different basic tests that you've seen on the course. So as simple as that, what we've done is set up all the properties on the command line using the -d, which is unique to our JVM. Now I could well have environment variables set, but they're not being used because all the properties override those. And let's see this running from the IDE so you know how to configure it here. So you know that the driver has got defaults. I've set up the default browser to be Firefox. Here are the different browsers that the driver can use. Grid was the last one that I added into the enum. Firefox is in there. So if I run a test without doing anything, it should start on Firefox. So let me pick a test here. Let's use the navigation example. That's nice and simple. I'll run that test. It's saying it could not find any properties or environment variables, so it's starting up Firefox locally and it's going to run the test there. That's all stuff that you've seen before. Now what you might not have noticed before is that IntelliJ in its run section has now created a run configuration for that test. So we can have a look at that. Here's the navigation example test that we just ran. Here's the configuration that we've got. So you can see that there are VM options. I could, if I wanted, add in a -d command here. So I'm going to set that to Chrome. Now, when I run this test, it should pick up this config and it should run under Chrome. So there we go, using the property with Chrome starting ChromeDriver. Now what I can do then is edit the configuration again. Instead of having it come in as a property, I can have it come in as an environment variable. So if I add an environment variable, I'll add the name, then I'll click over, add the value, and make this Chrome, hit OK. Let me delete this property, do OK. If I run that test again, couldn't find the property, using the environment variable, running on Chrome. So I can configure the either via properties or environment variables using the run configuration here. Now typically what I'll do, if I edit the configurations, I'll show you. Generally, if I'm practicing with the command line, I might well add all the properties in here as -d. If I want to make it easier for me to edit, I'll use the environment variables because these come in as a list. What I also do is, because we've got defaults for each of these, and we can have defaults on JUnit, what I might well do is override things in the IDE by setting the defaults on JUnit. So what I might do is set up all the values in a default JUnit. So this is all my grid config set up as environment variables in JUnit. If I do OK here, and you see that what I did was, because I'd set this up before, I have an unnamed one over here, and then I can just copy and paste the parameters from that. But now with JUnit, if I delete the navigation example test profile in here, go back to the navigation example test, it should pick up the environment variables from the default JUnit one and start running it against the grid, which is what it's doing. So I can configure it in the code, or I configure it using the IntelliJ run configurations, and that makes it quite easy and fast to start up. So I can still use environment variables, which are configured normally outside IntelliJ, but I can change them within IntelliJ. I can also check that it works with the properties. So I've got a lot of flexibility just by using the run configuration within IntelliJ itself. Very often what I'll do as a quick hint and tip, if I'm experimenting a lot, I like the environment variables because I can edit these in a little GUI rather than -d, but very often what I'll do is if I don't want to use something, I'll just stick ignore up the front. That way it's there when I want to amend it again, but it won't be picked up because it's got a different name. So I very often do that there. I often do that in the environment variables outside as well. And after describing the previous driver code for the grid good enough, I tried to use it on BrowserStack and discovered that BrowserStack needs a slightly different configuration than a local grid or a SauceLabs grid. BrowserStack is another cloud-based grid and a SauceLabs competitor. So let's have a quick look at BrowserStack and see what the difference is in the config. The BrowserStack documentation is pretty clear. You go off to the browserstack.com, sign up for an account. I'm still using a trial account on there. You choose the Java documentation and it shows you all the code that you need in order to set this thing up. It has a custom URL just like SauceLabs where it has your username and an access code. And the only reason I'm not showing you the BrowserStack site is that the access code doesn't look like it'd be changed. So if I put the access code and accidentally show it in any of these videos, then I can't change it. So I'm showing you everything through slides that are a little bit more controlled. There's a handy set of drop downs there, so you can choose the operating system you want and the browser. You can also choose a resolution if you need to. I just left that as default, and it will show you the capabilities that you need to set. Now you can see that it doesn't use the platform capability on BrowserStack. So we need to define the operating system and the operating system version, which we didn't support in the current driver code. And we also need the ability to set a custom capability that BrowserStack uses called BrowserStack.debug. What this does is it starts recording screenshots when the test code is executing. BrowserStack doesn't record a movie in the same way that SauceLabs does. BrowserStack captures screenshots as it goes along. It will only capture those screenshots if we set the capability to do that. So we need the ability to set up custom capabilities. Just to recap, you can see that we supported all the configuration that SauceLabs needed. The browser name, the version, and the platform. BrowserStack uses the browser and the version, but not the platform. We need to set the OS and the OS version and the BrowserStack debug capability. I'm going to do this by creating environment variables or properties that have a prefix of WebDriver underscore grid underscore cap underscore X. So that's WebDriver grid capability X, essentially. And this will be followed by the actual name of the capability we want to set, and the value will be the value we want to set. So if I create an environment variable called WebDriver underscore grid underscore cap underscore X underscore OS, which equals Windows, then that will become OS capability, and the value will be Windows. Similarly, if I make it WebDriver grid cap X OS version, then that will be OS version capability, and it will have the value 7. So let's have a look at the code. So in the driver code here, you can see the changes I've made to support this additional flexibility. I'm basically going to look at all the environment variables and all the properties, and if any of the names start with WebDriver grid cap X, then I'll treat that as an extended capability and parse it to find out the capability name and the value. So you can see that I get the list of keys from the getEnv, and I get the same thing, the list of property names or keys from the system.getProperties, and pass that into a method. So let's see what that method, the add any valid extra capability to method, does. You see I haven't had to add much code into this grid part of the driver here. All the work is done by this. So again, there's not much code here. We've got a loop that runs through the set of names that are passed in. And if the name starts with WebDriver underscore grid underscore cap underscore X, then I use the get property or env method that we saw before to find a value for it. If the value exists, then I parse out the prefix, the WebDriver grid cap X, leaving me with the capability name, and then I get the value, and then I add that name and value into the capability list, and that's it. There are still grid configurations that this doesn't support, i.e. command line arguments, but again, this is good enough for the moment. That's famous last words. So I will quickly show you the different config approaches in IntelliJ for BrowserStack, SauceLabs, and TestingBot. TestingBot is another competitor for SauceLabs. It's very similar. In fact, I'm not going to recommend and compare and contrast the different cloud vendors here. Just to say that if you start looking at a cloud-based provider, you should probably evaluate them all, because they all have free trials, and some of them have ongoing free plans like SauceLabs. I think TestingBot as well does. I think the BrowserStack free plan runs out, but I'm sure you've got enough time to evaluate it within the time they give you. You should evaluate them all and see which one best meets your needs and fits your pricing plans or budgets. In this section, I'm just going to show you how I configured the driver to work with them. So you can see the run debug configuration section, and I've got 3 default configurations with the basic setup that I need for each cloud provider. The SauceLabs execution JUnit defaults, the TestingBot execution JUnit defaults, and the BrowserStack execution JUnit defaults. When I want to start running an @test methods against any of them, I copy these details from the default into the JUnit default config, so that any new executions use the cloud provider by picking up the config from the JUnit default that I've just copied this into. SauceLabs, which you can see here, uses the basics that we originally set up. And if I need to add any additional config to SauceLabs via capabilities, then I can create some using the WebDriver grid capx variables that you saw me set up. TestingBot is almost exactly the same as SauceLabs. It has a slightly different set of platform values. So you can see there I'm using platform Win7, and at the time of creating this video doesn't have quite as many up-to-date browsers, so I'm using browser version 37 of Firefox. But I didn't need to change the driver to run the test through TestingBot. BrowserStack uses more custom capabilities by default, and you really do want the BrowserStack.debug property set so that you can see the screenshots in the execution. And when I add any of these jobs to the continuous integration to run the tests against the cloud provider, I simply pass the environment variables in as -d properties, use it to the maven test command as you saw me do before. So I'm going to show you the basic setup of the Mac as a grid node. You can see here we've got the Mac screen being shown, and in addition I've also got some Windows desktops overlaid. The reason this is happening is to make it easy for me to record. I'm sharing my Mac through the Air server running on Windows, and I can overlay my Windows IDE and tools and things over the top of this if we need to. So it may not look like your standard Mac, and that's because I'm overlaying all different windows. So let's start. The first thing I'm going to do, I'm going to run the hub on Windows, and I'm going to run the node on the Mac. It doesn't really matter where we do this, but just to demonstrate that the Mac can run as a node. So let's start the hub on the Windows machine. So I'm just going to do a normal Java -jar Selenium server standalone. I'm using version 2.46. I'm going to start it in the role of the hub. Now I'm using straight defaults for this. I don't have any special JSON files going on this. So if I go over to the grid console from the Mac, which is connecting onto the Windows machine, we can see we've got the grid running, but no nodes are connected. So if we head over to the Mac proper now, I'll just show you what I've got here in the Finder. So all I've done is created a folder, I've called it grid, and into that folder I've downloaded the Selenium server standalone jar just from the Selenium HQ site. And since I'm going to use this Mac as a node, I've added the ChromeDriver in there, ready for later configuration, and I've added a node_mac JSON file that we'll use for configuration later. But first of all, I'll use the node without any configuration as a raw node, and we can see what happens. So I'm just going to register my Mac as a node. So I'll do java -jar Selenium server 2.46 in the role of a node to the hub on my machine, my hub machine IP address on port 444 grid register. So it says it's registered there. So if I jump back to the hub and do a refresh, there we go. We can see that the hub has registered. I should also see some registration messages in the hub console. There we go, so we've registered a node. Now you can see that because I haven't configured the node through a JSON file, the grid thinks that the Mac can do IE as well, and I haven't configured the Mac to work with Chrome, so even though Chrome is listed here, it would fail when we run tests against it. But if we ignore all that for the moment, and let's connect to this from IntelliJ and run an @test method. So in IntelliJ, if I look at the edit configurations, you see that I've created a default configuration for the local grid. Let me show you what that looks like. Now this is based on the SauceLabs one because it's very simple. It's just our normal grid config. And what I've basically done here is saying we want to use WebDriver grid because that's what our driver is set to. The hub URL is on our local host because I'm running IntelliJ from the Windows machine. I want to use browser Firefox, and I want to use the platform Mac, which is what the grid console was showing us that we had set up. So what I'm going to do is, and this is how I work when I'm working in IntelliJ, I copy this stuff, all these environment variables. Going to make sure I've not got anything left over from testing. I'm going to go over to the JUnit defaults, delete everything that's there, and then just paste in what we've just copied. So now this is the set of defaults that I had set up for the localhost grid, and now it's in under JUnit defaults. So any test that I run under JUnit now will pick up those defaults and will run across the grid and we'll use the Mac. So I will run the navigation example test. So if I do Control N here, that's it, navigation example test. So now to help us see what's going on, and I'll make sure our console is there so we can see the messages coming through from the grid. So if I run the navigation example test, so there we go. So you can see that in the environment variables that it's using the Mac. That browser that you saw pop up was the Mac Firefox, and you can see that the node that we've got running on the Mac has started a session, executed, and done. So we ran the test from our Windows machine in IntelliJ across the Windows hub onto the Mac node. And let's just check that we're right about Chrome and Internet Explorer not working. So you can see from the file setup that I have that ChromeDriver is in the same directory as the Selenium server. And because of this, it will be picked up if I say use Chrome. So I'll amend the config for navigation example test to use Chrome as the browser, run it, and it should run. I'll change the run config for the navigation example test to use Chrome on Mac. Let's run this. There we go, it's picked up Chrome and it's running. And the reason it can do that is because Chrome is in the same directory as the server. Now normally you won't have it set up like that. So I will simulate that here by renaming the ChromeDriver to not ChromeDriver. Now, if I run the test, and it can't find it. Because typically your ChromeDriver is going to be in a tools directory or some other place. And the same thing will happen if I configure it to use IE, which we'd expect because IE isn't on the Mac, but the hub thinks it is. So I'll change this. So I'll change this to iExplorer. And as expected, it failed. It couldn't find the capability. We generally fix these issues by configuring where the ChromeDriver is from the startup command and configuring the capabilities of the node using the JSON files so that IE doesn't appear in the hub when we're using a Mac. So I can fix the ChromeDriver by passing it in as a parameter when we start the node. So this time I want to add the parameter -d WebDriver.chrome.driver equals, and then the path to where my ChromeDriver is. In this case it's renamed to not ChromeDriver. Now and we see we've told it where the ChromeDriver is, so it found it. So when we ran it with the Chrome as the driver, it managed to pick it up and run it. Now I can't do anything as simple with IE because IE is not on here, but remember to set up the ChromeDriver, I went off to the main ChromeDriver site, view all the ChromeDriver downloads, download the most recent one, bring down the Mac driver, unzip it, and there's the ChromeDriver that I need to use. So I'm running the hub on a fairly up-to-date Mac with Yosemite version of Mac operating system X10 installed, but it has registered with the hub as just Mac. If we have a quick look at the Selenium source code for platform.java, where all the magic for all this configuration happens, we'll see the different configuration options that we have. So I scrolled over all the Windows ones and you can see the Mac ones here. So I can see from the code that the family of the operating system is returned to the hub. So if I try and run the test against Yosemite, even though Yosemite is supported in platform.java, and even though that's what I'm running, the hub won't find the node. So let's try that. I'm going to change the config in IntelliJ to use Yosemite instead of Mac as the platform. I'll change this back to Firefox, just because that's the normal default, and run the test. So it's saying could not find that. Error forwarding session can't find the capability. So even though I'm running on Yosemite, and even though Yosemite is supported in the platform.java, we've registered it as a Mac. Okay, so if I start up the node using a config file, then we will get a different result. There's our console. Let me close down the old node, start up a new one, and the difference I'm going to add now is I'm going to say start it as a node, yes, register to that hub, yes, and with the node config from the node_mac.json file. So IntelliJ is still set up to use Yosemite, so let's run that test again. And this time it found it. So have a look at the hub config now. And we can see that I've created a node which only supports Firefox and Chrome, which is good because that's all that the Mac currently supports. And we've got operating system X 10.10, which is the Yosemite one. So I can also run this against OS X 10.10. And that runs fine, and you can see that that's down here. Yosemite is supported as Yosemite or OS X 10.10. You can see that the generic Mac is Mac Darwin OS X. So if I pass in OS X, it should still run. Now the difference there is, if I use the generic ones like OS X or Mac or Darwin, that will match pretty much anything. Snow Leopard, Mountain Lion, Mavericks, they'll all match under these. So if I have multiple Macs on my grid, the hub won't really be able to tell them apart if I choose OS X. I'm basically just saying I want to run it on a Mac. If I say I want to run it on Mavericks or Yosemite, then it will pick the correct node that I've got set up as Yosemite. So let's have a quick look at the JSON file that makes this magic possible. So this is pretty much a variant of the node.json file that you saw before. The only difference is in the capabilities here I've specified platform as Yosemite and Firefox, Yosemite and Chrome, and you can see that I've set up the hub host to be my Windows machine IP address, and the host is my Mac IP address. So the JSON files are really important when we want to be very specific about the nodes that we have in our grid and the nodes that we want to run tests on. I mean, that's why we put in the browser versions that we want to hit, because we can specify particular nodes with that. If I have a Mac that's on Yosemite and a Mac that's on Mavericks, I can distinguish between them using the platform. I have added the Mac and Windows JSON and batch files into the main code.zip file and in the repo. So if you're looking in the zip file, you'll find them in this grid config folder. There's a little readme explaining it. We've got the Mac node.json and we've got the Windows batch files and hub and node.json that you saw before. And if you're in the normal repo, in the normal code base, it's just there in your code folder in the grid config with the same layout. And now I'm going to show you how to use the open project functionality in IntelliJ to get your pom.xml file into IntelliJ. The main difference between importing and opening is that with an import you define the JDK and the source downloading and various other options at the time of import. With an open you may have to do that on the fly as you code and you work with your automation project. And once you've opened it, again, you just update the POM file to refer to the version of JUnit you want and add the version of Selenium you want. But the first thing we have to do is open it. So let's start IntelliJ. Then I'm going to choose the Open Project option. Now I want to open the pom.xml file that I've created. So I just copy that path in here. Then you can see that it's saying I can open this as a project. It's not an IntelliJ project yet, but it's found a POM file, so it's quite happy opening that. So I'm going to say OK. And you can see that IntelliJ has pretty much done everything automatically. Now we might find that when we start running things or start working with it, that it hasn't set up the SDK. In order to fix that, we would have to right click on the project and do open module settings, and then we can see that there's a SDK set up on the project, and the libraries and things that we're using are all in here. We could set up the SDKs at the platform level if we have to. So the easiest way of guaranteeing that it's going to work is with the import, but the easiest way of actually opening the project, and if your Maven file is set up fully, is using the open command. It's your choice which one you work with, but both have the end result that it's created a project. If I close IntelliJ here, you can see that it's created the .ida folder and the .iml file that IntelliJ uses. So now this is an IntelliJ. And we're approaching the end now. When you use this live, you will undoubtedly encounter problems that we have not covered here. A simple example, using XPaths, I had to convert completely to CSS selectors for a site that I was testing. You will probably start with CSS selectors, but you may need to drop down to XPath. You need to learn all this stuff. You will encounter synchronization problems that we haven't covered. You will need to use the user interactions in ways that we haven't gone through here, because we're trying to give you examples. But throughout the entire course, I've been trying to help you see that using code completion, we can see what the API offers us. Using the documentation that the tool gives us, we can see what it offers us. You have to learn to work in that type of mentality, because you will need to download and read the source code as you test. That's going to be your best resource as you go forward. Because this is just the start, right? Everything we've covered here, this is just the start. You need to be exploring the API, look into the code, find other people's example code, start reading more blogs, and always look at things and go, what on earth is that for when you find it in the code? That's how I have found parts of the API that were in beta and coming through. That's how I figured out different aspects that I could use in more detail. That's how you're going to learn. That's going to be your ongoing learning process. If you want to practice, you've seen a lot of these pages. If you go off to compendiumdev.co.uk/Selenium, there's a lot of pages there. And if you want to see the scope of the pages that are there, look in the source code, because all the source code for those pages is available on Bitbucket, on AJ Richardson Selenium test pages. If you go there, you can download that, you can install it locally, or you can just see the scope of other pages that are in there for use. I also have a trickier set of pages to automate that you can find on Bitbucket or in the showcase URL. And this is basically a lighter weight version of the GWT showcase, which is a monster. And they've got a really good live site that you can use to test with. Learn the programming language that you're going to use.
Throughout this course it's been Java, so I'm going to recommend that you read Agile Java by Robert Martin. It's a great book for giving you the fundamentals of Java using TDD. Effective Java by Joshua Bloch, which again is a great book for learning the intricacies and in more detail some of the patterns that you use for Java. Implementation Patterns is a really good book which helps encourage you to keep your coding simple but readable and effective and well refactored. And Growing Object-Oriented Software Guided by Tests by Steve Freeman and Nat Price is another really good book for helping you see how tests can influence your coding style and building up the various layers of abstraction that you need. And I kind of recommend them in this order. So if you've already got the basics, you might want to start at Effective Java and work your way through. These are kind of my favorite Java books. If you want live pages to challenge yourself, because people are always asking for live pages, use the GWT showcase. That has some real challenges because things are generated on the fly. It can be quite hard to automate. Prime Faces is very similar. Prime Faces and Rich Faces, last time I checked, used WebDriver in their tests for writing the code. So you've actually got examples that you can use to help learn more about using WebDriver on those sites. So my details, because I write about Selenium outside, so if you go to seleniumsimplified.com, that's my main Selenium and automation blog, but I also write about testing at eviltester.com and compendiumdev.co.uk. You can find me on Twitter at EvilTester. You can contact me and I will attempt to answer questions. And all your questions, remember, will probably end up making their way into the lectures in some form or other. So thank you very much for sticking with it this far. Really, the emphasis now is on you to practice and use this more. So thanks for sticking through the course. I appreciate it's not the best of backgrounds. This is not a green screen. I haven't got a suit on. I'm just here to say thank you because we've covered a lot of stuff. And if there's things you think I need to cover in more detail or just cover because we haven't missed them, we've missed them out and you want to know, then let me know. Leave comments and questions and I will answer them and probably create new lectures as a result of doing that. And if you liked the course, I'd appreciate if you left public feedback to encourage other people to learn Selenium and WebDriver with Java as well. And I encourage you, this is just the start, right? We've just started. I've gone over the basics, I've gone over the API, now it's time to use it. So use those pages that I created, the test pages, do more with them, experiment, try and chain things together. Use the live sites that I brought out, the Prime Faces, the GWT showcase. They are hard to automate, but they have the advantage that they're there. They will change. It's like working on a proper system, and they have tricky aspects. And make sure that you read the books. Keep reading and learning more about Java. I'm constantly learning more about Java to improve my test frameworks and my tests and make them more reliable. And the most important thing is to make sure that you read the Selenium documentation and the source code. That is what is up to date. That is what is using. You will find things in there that I haven't covered because they didn't exist when I was doing this. And you will learn Selenium the more that you use it. So thank you for your time. Stick with it. Any comments and pass some feedback on. Thank you very much. And where do you go next? Well, I have quite a few websites where I post information about new courses, new books, new articles, new webinars. And you won't see that information on this course or via announcements on this course. So browse these sites, sign up for the email lists or subscribe to the RSS feeds to stay up to date. CompendiumDev.co.uk is my main hub site. I tend to link to all my other sites and products and news from this site. My other sites are more specialized. JavaForTesters.com is my site to help testers learn to program in Java with the associated libraries. I have a book, I write blog articles and post videos using my YouTube channel. SeleniumSimplified.com is my Selenium WebDriver site. I link to my Selenium WebDriver books and training and post articles and new information on Selenium WebDriver. Some of these articles can cover pretty advanced topics. EvilTester.com is my main opinions site and technical and exploratory testing site. There's also a blog where I post the information. I'm part of the Black Ops testing group. We run free webinars as well as face-to-face training. We have a mailing list that you can sign up for, and you can learn about all the things we do via that. My YouTube channel, youtube.com/EvilTesterVideos, has a lot of free videos that I post and release, and you can subscribe to this channel to be kept up to date. As well as the RSS feeds on all my blogs, I use Twitter @EvilTester, where I drip feed links and news articles. Now over time I will add other sites and other social media channels, but I'm sure I'll link to them from one or more of the sites here, so if you're subscribed to those you'll stay up to date. So do investigate these links. I guarantee that there will be free and useful information there, and I encourage you to stay up to date with these sites. Sign up to the RSS feeds, the mailing lists, subscribe to the YouTube channel, subscribe to the Twitter feed to get new deals, free webinars, up-to-date information that I release outside this course. So follow this up, and here is to your continued learning. Best of luck.